Hello. Hello, hello, hello. Uh, oh, let's get some music going. Skip. There we go. What do we got? Still on shuffle. Good. Alright. We left off on animation. Um, let's see. Um, 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 uh, oh. I should probably notify the stream is gone. Now live. Now where is it? There it is. Shareable link. Nice. Alright, let's see. No, this is the wrong account. Alright. Cool. And back here. Alright, animation! Yay! This section of the tutorial covers using the two animation nodes in Godot and the animation editor. Introduction to the animation feature. Introduction to animation features. The animation player node allows you to create anything from simple to complex animations. In this guide, you learn to work with the animation panel, animate any property of any node, create a simple animation. In Godot, you can animate anything available in the inspector, such as node transform, sprites UI, elements, particles, visibility, and color of materials, and so on. You can also modify values of script variables and even call functions. Create an animation player node. To use the animation tools, we first have to create an animation player node. The animation player node type is the data container for your animations. One animation player node can hold multiple animations, which can automatically transition to one another. Animation player node. After you create an animation node, click on it to open the animation panel at the bottom of the viewport. We could probably do this. So let me create a new one. Animation. Doesn't really matter. Alright. Other node. Animation player. Great. Alright. The animation player is a data container for animations. One animation player node can hold multiple animations, which can automatically transition to one another. After you create an animation player node, click on it in the to open the animation panel at the bottom of the viewport. Oh, it's already open. Great. The animation panel consists of 4 parts. It shows track, timeline, and animation controls over here, but I don't see that here. Oh, and then of course animation controls up here. Animation controls, i.e. add, load, save, and delete animations. The tracks list, the timeline with keyframes, the timeline and track controls, where you can zoom the timeline, and edit tracks, for example. Computer animation relies on keyframes. A keyframe defines the value of a property at a point in time. Diamond shapes represent keyframes in a timeline. A line between two keyframes indicates that the value doesn't change between them. Keyframes in Godot. You set values of nodes, properties, and create animation keyframes for them. When the animation runs, the engine will interpolate the values between the keyframes, resulting in them gradually changing over time. It's not telling me to really do anything, so I'll just pull it back over here. The timeline defines how long the animation will take. You can insert keyframes at various points and change their timing. Each line in the animation panel is an animation track that references a normal or transform property of a node. Each track stores a path to a node and its affected property. For example, the position track in the illustration refers to the position property of the Sprite 2D node. Tip: if you animate the wrong property, you can edit a track's path at any time by double-clicking on it and typing the new path. The animation using the play from the beginning button, or pressing Shift-D on the keyboard to see the changes instantly. Tutorial creating a simple animation. Scene setup. Oh, interesting. So we're gonna need a Sprite 2D, and then from that animation player. We'll create a simple node with the animation player as its child. We will animate the sprite to move between 2 points on the screen. Warning: animation player inherits from node instead of node 2D or node 3D, which means that the child nodes will not inherit the transform from the parent nodes due to a bared node being present in the hierarchy. Therefore, it is not recommended to add nodes that have a 2D or 3D transform as a child of an animation player node. The sprite holds an image texture. For this tutorial, select the Sprite 2D node, click Texture in the inspector, and then click Load. Select the default Godot icon for the sprite's texture. Or just do that. That works perfectly fine. Select the animation player node and click on Animation button in the animation editor from animation button from the list, select New. To add a new animation, enter name for the animation in the dialog box. New animation works. Managing animation libraries. For reusability, the animation is registered in a list in the animation library resource. If you add an animation to an animation player without specifying any particular settings, the animation will be registered in the global animation library that animation player has by default. Where is that? Here? I don't know where that's located that it's talking about. If there are multiple animation libraries, you try to add an animation, a dialog box will appear with options. Global new library. Adding a track. To add a new track to our sprite, select it and take a look at the toolbar. Oh, up here. These switches and buttons allow you to add keyframes for the selected node's location, rotation, and scale. Since we are only animating the sprite's position, make sure that the only location switch is selected. Location. translation, rotation, scale. The selected switches are blue. Rotation scale, since we are only animating sprite's position, make sure that the location switch, only the location switch. I think it means position. Select the key button to create the first keyframe. Since we don't have a track set up for position property yet, Godot will offer to create it for us. Click create. What? Click on the key button. Key button? What do you mean key? Oh, this? Okay, create. There we go. Figured it out. The second keyframe, we need to set our sprite's end location and how long it will take to get there. Let's say we want to make it 2 seconds to move between 2 points. By default, the animation is set to last only 1 second. So change the animation length to 2 in the controls on the right side of the animation panel's timeline header. Right here. Whoa. Now move the sprite right to its final position. You can use the Move tool in the toolbar or set the position's X value in the inspector. Let's set it to right here. Click on the timeline header near 2-second mark in the animation panel and then click the key button. Key. Key button in the toolbar to create the second keyframe. Click on the play from the beginning button. Yep, that works. Autoplay on load to make you can make it so the animation automatically plays when the animation player node scene starts or joins another scene. To do this, click the autoplay on load button in the animation editor. It's right next to the edit button. The icon for it will also appear in front of the name for the animation, so you can easily identify which is the autoplay animation. Godot has an interesting feature that we can use in animations. When animation looping is set, but there is no keyframe specified at the end of an animation, the first keyframe is also the last. This means we can extend the animation length to 4 seconds now, and Godot will also calculate the frames from the last keyframe to the first, moving our sprite back and forth. So if we... What? Animation looping? Oh, right here. Ah, okay. You can change this behavior by changing the track's loop mode. This is covered in the next chapter. Track settings. Each property track has a settings panel at the end where you can set its update mode, track interpolation, and loop mode. The update mode of a track tells Godot when to update the property values. This can be continuous, update the property on each frame. Discrete, only update the property on keyframes. Capture. If the first keyframe's time is greater than 0, the current value of the property will be remembered and will be blended with the first animation key. For example, you could use the capture mode to move a node that's located anywhere in a specific location. Track mode. You'll usually use continuous mode. The other types are used to script complex animations. Track interpolation tells Godot how to calculate the frame values between keyframes. These interpolation modes are supported. Nearest, set the nearest keyframe value. Linear, set the value based on linear function calculation between the two keyframes. Cubic, set the value based on cubic function calculation between the two keyframes. Linear angle only appears in rotation property. Linear mode with the shortest path rotation. Cubic angle only appears in rotation property. Cubic mode with shortest path rotation. Ah, cubic. Nice. With cubic interpolation, animation is slower at keyframes and faster between them, which leads to more natural movement. Cubic interpolation is commonly used for character animation. Linear interpolation animates changes at a fixed pace, resulting in a more robotic effect. Godot supports two loop modes, which affect the animation when it's set to loop. Clamp loop and wrap loop. What is clamp loop? Ah, wrap loop. Loop modes, clamp loop interpolation. When this is selected, the animation stops after the last keyframe. For this track, when the first keyframe is reached again, the animation will reset to its value. Wrap loop interpolation. When this is selected, Godot calculates the animation after the last keyframe to reach the values of the first keyframe again. Keyframes for other properties. Godot's animation system isn't restricted to position, rotation, and scale. You animate any property. If you select your sprite while the animation panel is visible, Godot will display a small keyframe button in the inspector for each of the sprite's properties. Click one of these buttons to add a track and keyframe to the current animation. So, in the inspector... But that's not going to do anything. Flip vertically, on the other hand. Oh, interesting. Let's move this here. Edit keyframes. You can click on a keyframe in the animation timeline to display and edit its value in the inspector. Here? Inspector, animation track key, edit. What? What? You can click on a keyframe in the animation timeline to display it and edit it in the inspector. Oh, just right here. Keyframe editor, editing a key. You can also edit the easing value for a keyframe here by clicking and dragging its easing curve. This tells Godot how to interpolate the animation property when it reaches this keyframe. You can tweak your animations this way until the movement looks right. Interesting. Using reset tracks. For existing tracks, you can add an animation called reset, case sensitive, and add tracks for each property you want to reset. The only keyframe should be at time 0 and give it the desired default value for each track. If animation players reset on save, property is set to true. The scene will be saved with the effects of the animation applied, as if it had been synced to time 00. This only affects a saved file. The property tracks and the editor stay where they were. If you want to reset tracks in the editor, select the animation player node, open the animation button panel, then choose apply reset in the animation editor's edit drop-down menu. Huh? Animation players reset on save. Reset tracks in the editor, select the animation player node. Open the animation button. Open the animation bottom panel. Select the animation player node, open the animation bottom panel. Then choose apply reset. Where is that? In the animation editor's edit drop-down menu. Oh, okay. When using the keyframe icon next to a property in the inspector, the editor will ask you to automatically create a reset track. Reset tracks are also used as reference values for blending. See also for better blending. Onion skinning. Godot's animation editor allows you use onion skinning while creating an animation. To turn this feature on, click the onion icon. Oh, right here. On top right of the animation editor. Now there will be transparent red copies of what is being animated in its previous positions in the animation. There should be. The dots button next to the onion skinning button opens a drop-down menu that lets you adjust how it works, including the ability to use onion skinning for future frames. Three steps. What? no idea what that did. Linear. Free. Balanced. Yeah, I'm not getting those. Animation markers. The animation markers can be used to play a specific part of an animation rather than the whole thing. Here's a use case example. There's an animation file that has a character doing two distinct actions, and the project requires the whole animation, as well as both actions individually. Instead of making two additional animations, markers can be placed on the timeline, and both actions can now be played individually. To add marker to an animation, right-click the space above the timeline and select Insert Marker. New marker. That works. All markers require a unique name within the animation. You can set the color of the markers for improved organization. To play the part of the animation between two markers, use the play section with markers and play section with markers backwards method. If no start marker is specified, then the beginning of the animation is used, and if no end marker is specified, then the end of the animation is used. If the end marker is after the end of the animation, then the animation player will clamp the end of this section so it does not go past the end of the animation. Ooh. Okay. If the end marker is at the end of the now the play animation buttons will act as if the selected area is the whole animation. Play animation from start will treat the first marker as the start of the animation. Play animation backwards from end will treat the second marker as the end, and so on. Animation track types. This page gives an overview of the track types available for Godot's animation player node on top of the default property tracks. See also, we assume you already read Introduction to the Animation Features, which covers the basics including property tracks. Property track, the most basic track type. See Introduction to Animation Features. Position 3D, Rotation 3D, Scale 3D track. Blend shape track. Blend shape track is optimized for animation blending shape in Mesh Instance 3D. Ported from external 3D models. Call method track. A call method track will allow you to call a function at a precise time from within an animation. For example, you can call queueFree to delete a node at the end of a death animation. Note: the events placed on the call method track are not executed when the animation is previewed in the editor for safety. Well, to create such a track in the editor, click Add Track, call method track. Then a window opens and lets you select the node to associate with the track. To call one of the node's methods, right-click on the timeline and select Insert Key. The window opens with a list of available methods. Double-click one to finish creating the keyframe. To change the method call or its argument, click on the key and head in the inspector dock. There you can change the method to call. If you expand the arguments section, you will see a list of arguments you can edit. To create such a track through code, pass a dictionary that contains the target's method name and parameters as the variant for key in animation track insert key. The keys are expected value. The keys and their expected values are as follows. Method, the name of the method as a string. Arguments, the arguments to pass the function as an array. Bezier curve track. The Bezier curve track is similar to a property track, except it allows you to animate a property's value using a Bezier curve. Huzzah. Note, Bezier curve track and property track cannot be blended in Animation Player and Animation Tree. To create one, click Add Track. Bezier curve track. Okay. As with the property tracks, click Add Track, Bezier curve track. It's not being very specific. Here. As with property tracks, you need to select a node and a property to animate. To open a Bezier curve editor, click the curve icon to the right of the animation track. In the editor, keys are represented by filled diamonds and the outline diamonds connected to them by the line control curves shape. Tip: for better precision while manually working with curves, you might want to alter the zoom levels of the editor. The editor on the bottom right of the editor can be used to zoom in and out on the time axis. You can do that with the Control-Shift mouse wheel. Using Control-Alt mouse wheel will zoom in and out on the y-axis. Oh, what? That's weird. Well, the keyframe is selected, not the handle. Stop. Why is it green? Why are you green? Why is everything green? Why? Why are you green? I'm gonna pull you up. Okay. Um, Keyframe is selected, not the handle. Here, just gonna insert a bunch of keys. No, I want that, there we go. Where are you? What the? Oh, that is weird. Why are you green? Keyframe is selected, not the handle. Free allows you to orient a manipulator in any direction without affecting the other's position. Linear does not allow rotation of the manipulator and draws a linear graph. Balanced makes it so manipulators rotate together, but the balance between the key and the manipulator is not mirrored. Mirrored makes the position of one manipulator perfectly mirror the other, including their distance to the key. Audio playback track. If you want to create an animation with audio, you need to create an audio playback track. To create one, your scene must have either an audio stream player 2D, or audio stream player 3D node. When creating the track, you must select one of those nodes. To play a sound in your animation, drag and drop an audio file from the file system dock onto the animation track. You should see the waveform of your audio file in the track. To remove a sound from the animation, you can right-click on it and select the delete keys, or click on it and press the delete key. The animation mode allows you to choose whether or not to adjust the audio volume when blending in the animation tree. Animation playback track. Animation playback tracks allow you to sequence the animations of other animation player nodes in the scene. For example, you can use it to animate several characters in a cutscene. To create an animation playback track, select New Track, Animation Playback Track. To add an animation to the track, right-click on it and insert a key. Select the key you just created to select an animation in the inspector dock. I'm just gonna pull this back over here. If an animation is already playing and you want to stop it early, you can create a key to have it set to stop in the inspector. Note, if you instanced a scene that contains an animation player into your scene, you need to enable editable children in the scene tree to access its animation player. Also, an animation player cannot reference itself. Adderall. Adderall. Let's see. Yeah. Why not? And that should show up. Yeah, it did. Great. Let's see. Emotes. Why is it like that? Ew. Where is it? There's one that I'm looking for in specific. Let's see. Down. Why not? See how well it shows up in the face red heart shape. Oh, that's silly. That means I need to change this. Or not, I guess. Well. Work in progress. Okay. Cutout animation. What is it? Traditionally, cutout animations is a type of stop-motion animation in which pieces of paper or other thin material are cut into special shapes and arranged in two-dimensional representations of characters and objects. Characters' bodies are usually made out of several pieces. The pieces are arranged and photographed once for each frame of a film. The animator moves and rotates the parts in small increments between each shot to create the illusion of movement when the images are played back quickly in sequence. Simulations of cutout animation can now be created using software as seen in South Park and Jake and the Neverland Pirates. In video games, this technique has also become popular. Examples of this are Paper Mario or Rayman Origins. Cutout animations. Godot provides tools for working with cutout rigs and is ideal for the workflow. The animation system is fully integrated with the engine. This means animations can control much more than just motion of objects. Textures, sprites, sprite size, pivots, opacity, color modulation, and more can all be animated and blended. Combined animation styles. Animated Sprite 2D allows traditional cell animation to be used alongside cutout animation. In cell animation, different animation frames use entirely different drawings rather than the same piece positioned differently. In an otherwise cutout-based animation, cell animation can be used selectively for complex parts such as hands, feet, changing facial expressions, etc. Custom shape elements. Custom shapes can be created with Polygon 2D, allowing UV animation, deformations, etc. Particle systems. A cutout animation rig can be combined with particle systems. This can be useful for magic effects, jetpacks, etc. Custom colliders. Set colliders and influence areas in different parts of a skeleton, great for bosses and fighting games. Animation tree allows complex combinations and blending between several animations the same way it works in 3D. Making of Gbot. For this tutorial, we'll use a demo content, the pieces of Gbot character created by Andreas Essau. Get your assets. Cutout animation assets.zip. Setting up the rig. Create an empty node 2D as root of the scene. We will work under it. First node of the model is a hip, generally both in 2D and 3D. Hip rotation is skeleton. This makes it easier to animate. Torso. Rotation pivot. Set the rotation pivot down there. Yep. Remote transform 2D node. Transforms nodes somewhere else in the hierarchy. This node applies its own transform, including any transformation it inherits from its parents, to the remote node it targets. This allows us to correct the visibility order of our elements, independently of the locations of those parts in the cutout hierarchy. Tasty. Create a remote transform 2D node as a child of the torso, call it remote arm 1. That's a silly looking skeleton. Why are you looking at me like that? Stop that. It's creepy. The resulting rig will be easy to animate. By selecting the nodes and rotating them, you can animate forward kinematics efficiently. For example, for simple objects and rigs, this is fine, but there are limitations. Selecting sprites in the main viewport can become difficult in complex rigs. A scene tree ends up being used to select parts instead, which can be slower. Inverse kinematics is useful for animating extremities like hands and feet, and can't be used with our rig in its current state. To solve these problems, we'll use Godot's skeleton. Skeletons in Godot, there is a helper to create bones between nodes. The bone-linked nodes are called skeletons. As an example, let's turn the right arm into a skeleton. To create a skeleton, a chain of nodes must be selected from top to bottom. Then click the skeleton menu and select Make Bones. Bones. This will add bones covering the arm, but the result may be surprising. Why does that hand lack a bone? In Godot, a bone connects a node with its parent, and there's currently no child of the hand node. With this knowledge, let's try again. The first step is creating an endpoint node. Any kind of node will do, but Marker 2D is preferred because it's visible in the editor. The endpoint node will ensure that the last bone has orientation. Now select the whole chain from the endpoint of the arm and create bones. What is this? Dual Destinies, Florent Labelle. That's what it was. The result resembles a skeleton a lot more, and now the arm and forearm can be selected and animated. Create endpoints for all important extremities. Generate bones for all articulable parts of the cutout, with the hip as the ultimate connection between all of them. You may notice that an extra bone is created when connecting the hip and torso. Godot has connected the hip node to the scene root and a bone, and we don't want that. To fix this, select the root and hip node, open the skeleton menu, click Clear Bones. Interesting. What is it? I don't know what the proper shit for this is, but You might have noticed a second set of endpoints on the hands. This will make sense soon. Now the whole figure is rigged. The next step is setting up the IK chains. IK chains allow for more natural control of extremities. IK chains. IK stands for inverse kinematics. What the? Okay. It's a convenient technique for animating the position of hands, feet, and other extremities of rigs like the one we've made. Imagine you want to pose a character's foot in a specific position on the ground without IK chains. Each motion of the foot will require rotating and positioning several other bones, the shin and the thigh at least. This would be quite complex and lead to imprecise results. IK allows us to move the foot directly while the shin and thigh self-adjust. Note, IK chains in Godot currently work in the editor only, not at runtime. They are intended to ease the process of setting keyframes and are not currently useful for techniques like procedural animation. To create an IK chain, select a chain of bones from an endpoint to the base for the chain. For example, to create an IK chain for the right leg, and select the following. Then enable this chain for IK. Go to Edit, make IK chain. T. As a result, the base of the chain will turn yellow. Once the IK chain is set up, grab any child or grandchild of the base of the chain, example, a foot, and move it. You'll see the rest of the chain adjust as you adjust its position. Animation tips. The following section will be a collection of tips for creating animation for your cutout rigs. For more information, see for more information on how the animation system in Godot works, see Introduction to the Animation Features. Setting keyframes and excluding properties. Special contextual elements appear in the top toolbar when the animation editor window is open. Keep seeing shit out of the corner of my eye out this window. But there's nothing. Nada. Zip. Zilch. Gah. Yeah. Why? Why is there nothing? Setting keyframes and excluding properties. Special contextual elements appear in the top toolbar when the animation editor window is open. The key button inserts location, rotation, and scale keyframes for the selected objects or bones at the current playhead position. The location, rotation, and scale toggle buttons to the left of the key button modify its function, allowing you to specify which of the three properties keyframes will be created for. Here's an illustration of how this can be useful. Imagine you have a node which already has two keyframes animating its scale only. You want to add an overlapping rotation movement to the same node. The rotation movement should begin and end at different times from the scale change that's already set up. You can use the toggle buttons to have only rotation information added when you add a new keyframe. This way you can avoid adding unwanted scale keyframes, which would disrupt the existing scale animation. Creating a pose. Think of a rest pose as default pose that your cutout rig should be set to when no other pose is active in your game. Create a rest pose as follows. Nah, I'm gonna make it an A pose. Make sure the rig parts are positioned in what looks like a resting arrangement. Create a new animation, rename it Rest. Select all nodes in your rig. Box selection should work fine. Make sure the location, rotation, and scale toggle buttons are all active in the toolbar. Press the key animation. Keys will be inserted for all selected parts, storing their current arrangement. This pose can now be recalled when necessary in your game by replacing the rest animation you've created. Modifying rotation only. When animating a cutout rig, often it's only the rotation of the nodes that needs to change. Location and scale are rarely used. So when inserting keys, you might find it convenient to have only the rotation toggle active most of the time. This will avoid the creation of unwanted animation tracks for position and scale. Keyframe IK chains. When editing IK chains, it's not necessary to select the whole chain to add keyframes. Selecting the endpoint of the chain and inserting a keyframe will automatically insert frames for all other parts of the chain too. Visually move a sprite behind its parent. Sometimes it is necessary to have a node change its visual depth relative to its parent node during an animation. Think of a character facing the camera who pulls something out from behind his back and holds it out in front of him. During this animation, the whole arm and the object in his hand would need to change their visual depth relative to the body of the character. To help with this, there's a keyframe behind parent property on all Node 2D inheriting nodes. When planning your rig, think about the movements it will need to perform and give some thought to how you'll use behind parent and or remote transform 2D nodes. They provide overlapping functionality. Setting easing curves for multiple keys. To apply the same easing curve to multiple keyframes at once, select the relevant keys, click on the pencil icon in the bottom right of the animation panel. This will open the transition editor. In the transition editor, click on the desired curve to apply it. 2D skeletal deform. Skeletal deform can be used to augment a cutout rig, allowing single pieces to deform organically. Example, antennae that wobble as an insect character walks. This process is described in a separate tutorial. Work in progress. 2D skeletons. You know, I don't think that I'm actually going to do this. Ooh. What happened to... Ugh. Animation tree. Now this could work. Using animation tree. Introduction. With Animation Player, Godot has one of the most flexible animation systems that you can find in any game engine. It is pretty much unique in its ability to animate almost any property in any node or resource, and its dedicated transform bezier function calling audio and sub animation tracks. However, the support for blending those animations via Animation Player is limited, as you can only set a fixed crossfade transition time. Animation tree is a node designed to deal with advanced transitions. Okay, you can't hear that background. Animation tree and animation player. Before starting, know that an animation tree node does not contain its own animations. Instead, it uses animations contained in an animation player node. You create, edit, or import your animations in an animation player, and then use an animation tree to control the playback. Animation player and animation tree can be used in both 2D and 3D scenes. When importing 3D scenes and their animations, you can use name suffixes to simplify the process and import with the correct properties. At the end, the imported Godot scene will contain the animations in the animation player node. Since you rarely use imported scenes directly in Godot, they are either instantiated or inherited from. You can place the animation tree node in your new scene, which contains the imported one. Afterwards, point the animation tree node to the animation player that was created in the imported scene. This is how it's done in the third-person shooter demo for reference. A new scene was created for the player with the character body 3D as root. Inside the scene, the original .dae collada file was instantiated and an animation tree node was created. Creating a tree. To use an animation tree, you have to set a root node. An animation root node is a class that contains and evaluates subnodes and outputs an animation. There are three types of subnodes. Animation nodes, which reference an animation from linked animation player. Animation root nodes, which are used to blend subnodes and can be nested. Animation blend nodes, which are used in an animation blend tree. A 2D graph of nodes. Blend nodes take multiple input ports and give one output port. A few types of root nodes are available. Animation node animation selects an animation from a list and plays it. This is the simplest root node and generally not used as a root. Animation node blend tree contains multiple nodes as children in a graph. Many blend nodes are available, such as mix, blend 2, blend 3, one shot, etc. Animation node blend space 1D allows linear blending between two animation nodes. Control the blend position in a 1D blend space to mix between animations. Animation node blend space 2D. Hello, Bella. What are you doing? Saying hi? Oh, bye. Okay. Animation node blend space 2D allows linear blending between three animation nodes. Control the blend position in a 2D blend space to mix between animations. Animation node state machine contains multiple nodes as children in a graph. Each node is used as a state. with multiple functions used to alternate between states. Blend tree. When you make an animation blend tree, you get an empty 2D graph in the bottom panel under the animation tree tab. It contains only an output node by default. In order for animations to play, a node has to be connected to the output. You can add nodes from the Add Node menu or by right-clicking an empty space. The simplest connection to make is to connect an animation node to the output directly, which will just play back the animation. Following is a description of the other available nodes. Blend 2, Blend 3. These nodes will blend between 2 or 3 inputs by a user-specific blend value. Blending can use filters to control individually which tracks get blended and which do not. This can be useful for layering animations on top of each other. For complex blending, it is recommended to use blend spaces instead. One shot. This node will execute an animation once and return when it finishes. You can customize blend times for fading in and out as well as filters. That's fairly simple. Time seek. This node allows you to seek to a time in the animation connected to its input. Use this node to play an animation starting from a certain playback position. Note that the seek request value is measured in seconds. So if you would like to play an animation from the beginning, set the value to 0, or if you would like to play an animation from 3 seconds in, to set the value to 3. Timescale. This node allows you to scale the speed of animation connected to its input. The speed of the animation will be multiplied by the number in the scale parameter. Setting the scale to 0 will pause any animation. Setting the scale to a negative number will play the animation backwards. Transition. This node is a simplified version of a state machine. You connect animations to the inputs, and the current state index determines which animation to play. You may specify a crossfade transition time in the inspector. You may change the number of input ports, or rearrange inputs, or delete inputs. State machine. When you make an animation node state machine, you get an empty 2D graph in the bottom panel under the animation tree. It contains a start and end state by default. To add states, right-click or use Create New Nodes button, whose icon is a plus in a box. You can add animation, blend spaces, blend trees, or even another state machine. To edit one of these more complex subnodes, click on the pencil icon on the right of the state to return to the original state machine. Click Root on the top left of the panel. Before the state machine can do anything useful, the states must be connected with transitions. To add a transition, click the Connect Nodes button, which is a line with a right-facing arrow, and drag between 2 states. You can create 2 transitions between states, one going in each direction. Wait, what? I can close that. I wonder where this has gotten to. There are three types of transitions. Immediate will switch to the next state immediately. Sync will switch to the next state immediately, but will seek the new state to the playback position of the old state. At end, will wait for the current state playback to end, then switch to the beginning of the next state animation. Transitions also have a few properties. Click a transition and it will be displayed in the inspector. X-fade time is the time to crossfade between this state and the next. X-fade curve is a crossfade following a curve rather than a linear blend. Reset determines whether the state you are switching into plays from the beginning, true or not, false. Priority is used together with the travel function from code. More on this later. Lower priority transitions are preferred when traveling through the tree. Switch mode is the transition type, see above. It can be changed after creation here. Advanced mode determines the advanced mode. If disabled, the transition will not be used. If enabled, the transition will only be used during travel. If auto, the transition will be used if the advanced condition and expression are true, or if there are no advanced conditions or expressions. Advanced condition and advanced expression. The last two properties in a state machine transition are advanced condition and advanced expression. When the advanced mode is set to auto, these determine if the transition will advance or not. Advanced condition is a true false check, or true or false check. You may put a custom variable name in the text field, and when the state machine reaches this transition, it will check if your variable is true. If so, the transition continues. Note that the advanced condition only checks if a variable is true, and it cannot check for falseness. This gives the advanced condition a very limited capability. If you want to make a transition back and forth, but based on one property, you would need to make two variables that have opposite values, and check if either of them are true. This is why in Godot 4 the advanced expression was added. The advanced expression works similar to advanced condition, but instead of checking if one variable is true, it evaluates any expression. An expression is anything you could put in an if statement. These are all examples of expressions that would work in an advanced expression. It's the same as the one before. Warning, the expression is case sensitive. If you reference engine properties such as velocity on character body node, you should use snake case naming conventions. If you reference script properties, you should match a style used in the script, which is typically snake case in GDScript and Pascal case in C#. Here's an example of an improperly set up state machine transition using advanced condition. This is not working because there is a exclamation variable in the advanced condition, which cannot be checked. Here is the same example set up properly between two opposite variables. Here's the same example, but using advanced expression rather than advanced condition, which eliminates the need for two variables. In order to use advanced expression, the advanced expression base node has to be set from the inspector of the animation tree node. By default, it's set to the animation tree node itself, but it needs to point to whatever node contains the script in your animation variables. See also, the advanced expression is evaluated using Godot's expression class. See evaluating expressions for more information on writing expressions. State machine travel. One of the nice features in Godot's state machine implementation is the ability to travel. You can instruct the graph to go from the current state to another one, while visiting all the intermediate ones. This is done via the A-star algorithm. If there is no path of transition starting at the current state and finishing at the destination state, the graph teleports to the destination state. To use the travel ability, you should first retrieve the animation node state machine playback object from the animation tree node. It is exported as a property, and then call one of its many functions. The state machine must be running before you can travel. Make sure to either call start or connect a node to start. Blend space and blend space 2D and blend space 1D. Blend Space 2D is a node to do advanced blending in 2 dimensions. Points representing animations are added to a 2D space, and then a position between them is controlled to determine the blending. You may place these points anywhere on the graph and right-click, or using the Add Point button, whose icon is a pen and point. Wherever you can place the points, a triangle between them will be generated automatically using a del on A. You can also control and label the ranges in X and Y. Finally, you may also change the blend mode. By default, blending happens by interpolating points inside the closest triangle. When dealing with 2D animations frame by frame, you may want to switch to discrete mode. Alternatively, if you want to keep the current play position when switching between discrete animations, there is a carry mode. This mode can be changed in the blend menu. Blend Space 1D works just like Blend Space 2D, but in one dimension. Aligned triangles are not used. You know, Okay, I was gonna say I might not use this, but then I was thinking about it, and then it's like, I might. No, actually, probably not. Playing videos. No. Okay, come here. Probably not creating movies either. So, we shall move on to assets pipeline. But before we read that, I'm gonna use the bathroom. Hello is back. Is back. Let me check Discord real quick. Da da da. Alright. Import process. Importing assets in Godot. To import assets in Godot, place your assets, image files, scenes, audio files, fonts, etc. directly in the project folder. Yeah, I know how to do this. So we can just skip over that. Audio. Now this is important. Audio buses introduction. Godot's audio processing code has been written with games in mind, with the aim of achieving an optimal balance between performance and sound quality. Godot's audio engine allows any number of audio buses to be created, and any number of effect processors can be added to each bus. Only the hardware of the device running your game will limit the number of buses and effects that can be used before performance starts to suffer. Decibel scale. Godot's sound interface is designed to meet the expectations of sound design professionals. To this end, it primarily uses the decibel scale. For those unfamiliar with it, it can be explained with a few facts. The decibel scale is a relative scale. It represents the ratio of sound power by using 20 times the base 10 logarithm of the ratio. 20 times logarithm 10 of the p over p0. For every 6 decibels, sound amplitude doubles or halves. 12 decibels represents a factor of 4, 18 decibels a factor of 8, 20 decibels a factor of 10, 40 decibels a factor of 100, etc. Since the scale is logarithmic, true 0, no audio, can't be represented. 0 decibels is the maximum amplitude possible in a digital audio system. This limit is not the human limit, but a limit for the sound hardware. Audio with amplitudes that are too high can be represented properly below 0 decibels, create a kind of distortion called clipping. To avoid clipping, your sound mix should be arranged so that the output of the master bus, more on that later, never exceeds 0 decibels. Every 6 decibels below the 0 decibel limit, sound energy is halved. It means the sound volume at -6 decibels is half as loud as 0 decibels. -12 decibels is half as loud as 6 decibels. And so on. When working with decibels, sound is considered no longer audible between -60 and -80 decibels, which makes your working range generally between -60 and 0 decibels. This can take a bit getting used to, but it's friendlier in the end and will allow you to communicate better with audio professionals. Audio buses. Audio buses can be found in the bottom panel of the Godot editor. An audio bus, also called an audio channel, can be considered a place that audio is channeled through. One way to play back through a device's speakers. Audio data can be modified and rerouted by an audio bus. An audio bus has a VU meter, the bars that light up when sound is played, which indicates the amplitude of the signal passed through. The leftmost bus is the master bus. This bus outputs the mix to the speakers, to your speakers, so as mentioned in the decibel scale section above, make sure your mix level doesn't reach 0 decibels in the bus. The rest of the audio buses can be flexibly routed. After modifying the sound, you send it to another bus on the left. The destination bus can be specified for each of the non-master audio buses. Routing always passes audio buses from the right to the furthest to the audio left. This avoids infinite routing loops. In the above image, the output of bus 2 has been routed to the master bus. Playback of audio through a bus. To playtest audio to a bus, create an audio stream player node. Load an audio stream and select a target bus for playback. Finally, toggle the playing property to on and sound will flow. See also, you may also be interested in reading about audio streams now. Oh, we'll get to that in 2 sections. Audio effects. Warning, this feature is not supported on the web platform and audio stream. Okay. Audio buses contain all sorts of effects. These effects modify the sound in one way or another and are applied in order. For information on what each effect does, see audio effects. Automatic bus disabling. There is no need to disable buses manually when not in use. Godot detects that the bus has been silent for a few seconds and disables it, including all effects. Disabling buses have a blue VU meter instead of a red-green one. Bus rearrangement. Stream players use bus names to identify a bus, which allows adding, removing, and moving buses around while the reference to them is kept. However, if a bus is renamed, the reference will be lost and the stream player will output to master. This system was chosen because rearranging buses is a more common process than renaming them. Default bus layout. The default bus layout is automatically saved to that file. Custom bus arrangements can be saved and loaded from disk. Okay, I'll be right back. I should go check on my laundry. Okay, guess not. Alright. Oh, this one's... It says... Okay, strange. Audio effects. Godot includes several audio effects that can be added to an audio bus to alter every sound file that goes through that bus. Try them all out to get a sense of how they alter sound. Here follows a short description of the available effects. Amplify. Amplify changes the volume of the signal. Some care needs to be taken though. Setting the level too high can make the sound digitally clip, which can produce unpleasant crackles and pops. Unpleasant? Nah, they're great. Band limit and band pass. These are resonant filters which block frequencies around the cutoff point. Band pass can be used to simulate sound passing through an old telephone line or megaphone. Modulating the band pass frequency can simulate the sound of a wah-wah guitar pedal. Think of the guitar in Jimi Hendrix's Voodoo Child Slight Return. I have no idea what that is. Never heard of it. Capture. The capture effect copies the audio frames of the audio bus that it is on into an internal buffer. This can be used to capture data from the microphone or to transmit audio over the network in real time. Hi. What? Oh. Oh, you're almost done. Sort of.
Yeah.
Nice. Nice. Can I show it?
Sure.
It's a spider lily. Definitely could do better on some parts, though. But I'm sure you're aware of that. I mean, you're the artist, after all.
I know.
Is that all?
Yeah.
Okay.
Bye.
Goodbye. The capture effect copies audio frames and the audio bus that it is in into an internal buffer. This can be used to capture data from the microphone or to transmit audio over the network in real time. Chorus, as the name of the effect implies, the chorus effect makes a single audio sample sound like an entire chorus. It does this by duplicating a signal and very slightly altering the timing and pitch of each duplicate. and varying that over time via an LFO, low frequency oscillator. The duplicates are then mixed back together with the original signal, producing a lush, wide, and large sound. Although chorus is traditionally used for voices, it can be desirable with almost any type of sound. Compressor, a dynamic range a compressor automatically attenuates ducks the level of an incoming signal when its amplitude exceeds a certain threshold. The level of an attenuation applied is proportional to how far the incoming audio exceeds the threshold. The compressor's ratio parameter controls a degree of attenuation. One of the main uses of a compressor is to reduce the dynamic range of signals with very loud and quiet parts. Reducing the dynamic range of a signal can make it fit more comfortably in a mix. The compressor has many uses. For example, it can be used in the master bus to compress whole output prior to being hit with a limiter, making the effect of the limiter much more subtle. It can be used in voice channels to ensure that they sound as even as possible. It can be sidechained by another sound source. This means it can reduce the sound level of one signal using the level of another audio bus for threshold detection. This technique is very common in video game mixing to duck the level of music or sound effects when in-game or multiplayer voices need to be fully audible. It can accentuate transients by using a slower attack. This can make sound effects more punchy. Note, if your goal is to prevent a signal from exceeding a given amplitude altogether, rather than reduce the dynamic range of the signal, a limiter is likely a better choice than a compressor for this purpose. However, applying the compressor before a limiter is still a good practice. Delay. Digital delay essentially duplicates a signal and repeats it at a specified speed with a volume level that decays for each repeat. Delay is great for simulating the acoustic space of a canyon or large room where sound bounces have a lot of delay between their repeats. This is in contrast to reverb, which has a more natural and blurred sound to it. Using this in conjunction with reverb can create very natural sounding environments. Distortion. Makes the sound distorted. Godot offers several types of distortion. Overdrive sounds like a guitar distortion pedal or megaphone. Sounds distorted like this sound, with this sound like they're coming through a low-quality speaker or device. Tan sounds like another interesting flavor of overdrive. Bit crushing clamps the amplitude of the signal, making it sound flat and crunchy. All three types of distortion can add higher frequency sounds to an original sound, making it stand out better in a mix. EQ. EQ is what all other equalizers inherit from. It can be extended with custom scripts to create an equalizer with a custom number of bands. EQ6, EQ10, EQ21. Godot provides 3 equalizers with different numbers of bands, which are represented in the title, 6, 10, and 21 bands respectively. An equalizer on the master bus can be useful for cutting low and high frequencies that the device's speakers can't reproduce well. For example, phone or tablet speakers usually don't reproduce low frequency sounds well, and could make a limiter or compressor attenuate sounds that aren't even audible to the user anyway. Note, the equalizer effect can be disabled when headphones are plugged in giving the user the best of both worlds. Filter. Filter is what all other filters inherit from and should not be used directly. Hard limiter. A limiter is similar to a compressor, but it's less flexible and designed to prevent a signal's amplitude exceeding a given dB threshold. Adding a limiter to the final point of the master bus is good practice, as it offers an easy safeguard against clipping. High-pass filter. Cuts frequencies below a specific cutoff frequency. High-pass filter is used to reduce the base content of a signal. High shelf filter reduces all frequencies above a specific cutoff frequency. Limiter. This is the old limiter effect, and it is recommended to use the hard limiter effect instead. Here is an example of how the effect works. If the ceiling is set to -12 decibels and the threshold is 0 decibels, all samples going through get reduced by 12 decibels. This changes the waveform of the sound and introduces distortion. This effect is being kept to preserve compatibility, however it should be considered deprecated. Low-pass filter cuts frequencies above a specific cutoff frequency and can also resonate, boost frequencies close to the cutoff frequency. Low-pass filters can be used to simulate muffled sound, for instance, underwater sounds, sounds blocked by walls, or distant sounds. Low shell filter reduces all frequencies below a specific cutoff frequency. Notch filter, the opposite of the bandpass filter, removes a band of sound from the frequency spectrum at a given cutoff frequency. Panner, the panner allows the stereo balance of a signal to be adjusted between the left and right channels. Headphones are recommended when configuring this effect. Phaser, the effect is formed by dephasing two duplicates of the same sound so they cancel each other out in an interesting way. Phaser reproduces a pleasant whooshing sound that moves back and forth through the audio spectrum, and can be a great way to create sci-fi effects or Darth Vader-like voices. Pitch shift. This effect allows the adjustment of the signal's pitch independently of its speed. All frequencies can be increased or decreased with minimal effect on transients. Pitch shift can be used to create unusually high or deep voices. Do note that altering pitch can sound unnatural when pushed outside of a narrow window. Record. The record effect allows a user to record sound from a microphone. Oh, record, not record. Reverb. Reverb simulates rooms of different sizes. It has adjustable parameters that can be tweaked to obtain the sound of a specific room. Reverb is commonly outputted from Area 3Ds, see reverb buses, or to apply a chamber feel to all sounds. Spectrum Analyzer. This effect doesn't alter audio, instead you add this effect to buses you want a spectrum analysis of. This wouldn't typically be used for audio visualization. Visualizing voices can be a great way to draw attention to them without just increasing their volume. A demo project using this can be found here. Stereo Enhance. This effect uses a few algorithms to enhance a signal's stereo width. Work in progress. Okay. Audio streams. Introduction. As you might have already read in audio buses, sound is sent to each bus via an audio stream player node. There are different kinds of audio stream players. Each one loads an audio stream and plays it back. Audio stream. An audio stream is an abstract object that emits sound. The sound can come from many places, but is most commonly loaded from the file system. Audio files can be loaded as audio streams and placed inside an audio stream player. You can find information on supported formats and differences in importing audio samples. There are other types of audio streams, such as audio stream randomizer. This one picks a different audio stream from a list of streams each time it's played back, and applies random pitch and volume shifting. This can be helpful for adding variation to sounds that are played back often. Audio stream player. This is the standard non-positional stream player. It can play to any bus in 5.1 sound steps. It can send audio to stereo mix or front speakers. Playback type is an experimental setting and could change in future versions of Godot. It exists so web exports use web audio API-based samples instead of streaming all sounds to the browser. Unlike most platforms, this prevents the audio from being garbled in single-thread web exports by default. By default, only the web platform will use samples. Changing this setting is not recommended unless you have an explicit reason to. You can change the default playback type for the web and other platforms in the project settings under Audio General. Advanced settings must be turned on to see the setting. Audio Stream Player 2D. This is a variation of Audio Stream Player, but emits sound in a 2D positional environment. When close to the left of the screen, the panning will go left. When close to the right side, it will go right. Note, Area 2Ds can be used to divert sound from any audio stream player 2Ds. They contain to specific buses. This makes it possible to create buses with different reverb or sound qualities to handle action happening in a particular parts of your game world. Audio stream player 3D. Same as 2D, but for 3D environments, I assume. Reverb buses, not supported on the web platform. Okay. Godot allows for 3D audio streams to enter a specific Area 3D node. Okay, that's Doppler. Warning, this feature is not supported on the web platform. This is also a 3D thing. think. When the relative velocity between an emitter and listener changes, this is perceived as an increase or decrease in the pitch of an emitted sound. Godot can track velocity changes in the audio stream player 3D and camera nodes. Both nodes have this property, which must be enabled manually. Enable it by setting it depending on how objects will be moved. Use idle for objects moving using process, or physics for objects moved using physics process. The tracking will happen automatically. Okay, I think that one is just for 3D shit. Work in progress. Sync the gameplay with audio and music. Introduction. In any application or game, sound and music playback will have a slight delay. For games, this delay is often so small that it is negligible. Sound effects will come out a few milliseconds after any play function is called. For music, this does not matter, as in most games it does not interact with gameplay. Still, for most games, mainly rhythm games, it may be required to synchronize player actions with something happening in a song, usually in sync with the BPM. For this, having more precise timing information for an exact playback position is useful. Achieving very low playback timing precision is difficult. This is because many factors are at play during audio playback. Audio is mixed in chunks, not continuously. Depending on the size of audio buffers used, check latency in project settings. Mixed chunks of audio are not played immediately. Graphics APIs display 2 or 3 frames late. When playing on TV, some delay may be added due to image processing. The most common way to reduce latency is to shrink audio buffers, again by editing the latency setting in the project settings. The problem is that when latency is too small, sound mixing will require considerably more CPU. This increases the risk of skipping. A crack in sound caused by a mixed callback was lost. This is a common trade-off, so Godot ships with sensible defaults that should not need to be altered. The problem in the end is not the slight delay, but synchronizing graphics and audio for games that require it. Some helpers are available to obtain more precise playback timing. Using the system clock to sync. As mentioned before, if you call audio stream player play, sound will not begin immediately, but when the audio thread processes the next chunk. This delay can't be avoided, but can be estimated by calling audioserver.getTime to next mix. The output latency, what happens after the mix, can also be estimated by calling audioserver.getOutput latency. Add these two, and it's possible to get almost exactly when sound or music will begin playing in the speakers during process. In the long run, though, as the sound hardware clock is never actually in sync with the system clock, the timing information will slowly drift away. For a rhythm game where a song begins and ends after a few minutes, this approach is fine, and it's a recommended approach. For a game where playback can last much longer time, the game will eventually go out of sync, and a different approach is needed. Use the audio hardware clock to sync. Use the audio stream player to .get playback position. To obtain the current position for the song sounds ideal, but it's not that useful as is. The value will increment in chunks every time the audio callback mixed a block of sound. So many calls can return the same value. Added to this, the value will be out of sync with the speakers too, because of the previously mentioned reasons. To compensate for the chunked output, there is a function that can help. AudioServer.getTime since last mix. Adding the return value from this function to get playback position increases position. To increase precision, subtract the latency latency how much it takes for the audio to be heard after it was mixed. The result may be a bit jittery due to how multiple threads work. Just check that the value is not less than the previous frame. Discard it if so. This is also a less precise approach than the one before, but it will work for songs of any length, or synchronizing anything, sound effects as an example, to music. Here's some code as before using this approach. Work in progress. Recording with microphone. Godot supports in-game audio recording for Windows, macOS, Linux, Android, and iOS. The simple demo is included in the official demo projects and will be used as support for this tutorial. You'll need to enable audio input in the audio driver enable input project setting, or you'll just get empty audio files. On iOS and iPadOS, it is also important to set the Advanced Audio General iOS Session category, setting to include record or play and record. The structure of the demo. The demo consists of a single scene. The scene includes two major parts, the GUI and the audio. We will focus on the audio part. In this demo, a bus named Record and the effect Record is created to handle the audio recording. An audio stream player named Audio Stream Record is used for recording. The audio recording is handled by the audio effect Record resource which has three methods. Get recording is recording active and set recording active. At the start of the demo, the recording effect is not active. When the user presses the record button, the effect is enabled with set recording active true. On the next button press, as effect is recording active is true, the recorded stream can be stored into the recording variable by calling effect get recording. To play back the recording, you assign the recording as the stream of the audio stream player and call play. To save the recording, you call save to WAV with the path to file. In this demo, the path is defined by the user via the line edit input box. Text to speech. Basic usage. Basic usage of text-to-speech involves the following one-time steps. Enable TTS in the Godot editor for your project. Query the system for a list of usable voices. Store the ID of the voice you want to use. By default, the Godot project level setting for text-to-speech is disabled. To avoid unnecessary overhead, to enable it, go to Product Settings and make sure the Advanced Settings toggle is enabled. Click on Audio General. Ensure the text-to-speech option is checked. Restart Godot if prompted to do so. Text-to-speech uses a specific voice depending on the user system. They might have multiple voices installed. Once you have the voice ID, you can use it to speak some text. Requirements for functionality. Godot includes text-to-speech functionality. You can find these under the display server class. Godot depends on system libraries for text-to-speech functionality. These libraries are installed by default on Windows, macOS, Web, Android, and iOS, but not on all Linux distributions. If they are not present, text-to-speech functionality will not work. Specifically, the TTS get voices method will return an empty list, indicating that there are no usable voices. Both Godot users on Linux and end users on Linux running Godot games need to ensure that their system includes the system libraries for text-to-speech to work. Please consult the table below or your own distribution's documentation to determine what libraries you need to install. Troubleshooting. If you get an error, invalid get index 0 on base packed string array or line or for the line variable voice ID equals voice 0, check if there are any items in voices. If not, all users make sure to you enable text-to-speech in project settings. Linux users ensure you install the system-specific libraries for text-to-speech. Best practices. Best practices for text-to-speech in terms of the ideal player experience for blind players is to send output to the player's screen reader. This preserves a choice of language, speech, speed, pitch, etc. that the user set, as well as allows advanced features like allowing players to scroll back and forward through text. As of now, Godot doesn't provide this level of integration. With the current state of Godot, text-to-speech API's best practices include develop the game with text-to-speech enabled and ensure that everything sounds correct. Allow players to control which voice to use, and save or persist that selection across game sessions. Allow players to control the speech rate and persist that selection across game sessions. This provides your blind players with the most flexibility and comfort available when not using a screen reader and minimizes the chance of frustration and alienating them. Caveats and other information. Expect delays when you call TTS speak and TTS stop. The actual delay time varies depending on both the OS and on your machine specifications. This is especially critical on Android and web, where some of the voices depend on the web services. And the actual time to playback depends on server load, network latency, and other factors. Non-English text works if the correct voices are installed and used. On Windows, you can consult the instructions in this article to enable additional language voices on Windows. Non-ASCII characters such as umlaut are pronounced correctly if you select the correct voice. Blind players use a number of screen readers, including JAWS and NVDA, voiceover, narrator, and more. Windows text-to-speech APIs generally perform better than their equivalents on other systems. Example, TTS stop followed by TTS speak immediately speaks a new message. Export. See, also, this section is about exporting a build of your project. If you're trying to export properties from a script, CGD script export properties, or C# export properties. Exporting projects. Why export? Originally, Godot did not have any means to export projects. The developers would compile the proper binaries and build the packages to each platform manually. When more developers and even non-programmers started using it, and when our company started taking more projects at the same time, it became evident that this was a bottleneck. On PC, distributing a game project on PC with Godot is rather easy. Drop the Godot binary in the same directory as the project.godot file. Then compress the project directory and you are done. Whose headphones allow for my headphones to explode off my head. It's silly. Then it sounds simple, but there are probably a few reasons why the developer may not want to do this. The first one is that it may not be desirable to distribute loads of files. Some developers may not like curious users peeking at how the game was made. Others may find it inelegant, and so on. Another reason is that the developer might prefer a specially compiled binary, which is smaller in size, more optimized, and does not include tools like the editor and debugger. Finally, Godot has a simple but efficient system for creating DLCs as extra package files. On mobile, the same scenario on mobile platforms is a little worse. To distribute a project on those devices, a binary for each of those platforms is built, then added to a native project together with the game data. This can be troublesome because it means that the developer must be familiarized with the SDK of each platform before even being able to export. While learning each SDK is always encouraged, it can be frustrating to be forced to do it at an undesired time. There is also another problem with this approach. Different devices prefer some data in different formats to run. The main example of this is texture compression. All PC hardware uses S3TC BC compression, and that has been standardized for more than a decade, but mobile devices use different formats for texture compression, such as ETC1 and ETC2. Export menu. After many attempts at different export workflows, the current one has proven to work the best. At the time of this writing, not all platforms are supported yet, but the support platforms continues to grow. To open the export menu, click the export button. To export the export menu will open, however it will be completely empty. This is because we need to add an export preset. To create an export preset, click the add button at the top of the export menu. This will open a drop-down list of platforms to choose from the export preset. The default options are often enough to export, so tweaking them is usually not necessary. However, many platforms require additional tools, SDKs, to be installed to be able to export. Additionally, Godot needs export templates installed to create packages. The export menu will complain when something is missing and will not allow the user to export for that platform until they resolve it. At that time, the user is expected to come back to the documentation and follow instructions on how to properly set up that platform. The buttons at the bottom of the menu allow you to export for the project in a few different ways. Export all. Export the project as a playable build, Godot executable, and project data. For all the presets defined, all presets must have an export path defined for this to work. Export project. Export the project as a playable build, Godot executable, and project data for the selectable preset. Export package or zip. Export the project resources as a package or zip package. This is not a playable build. It only exports the project data without a Godot executable. Export templates. Apart from setting up the platform, the export templates must be installed to be able to export projects. They can be obtained as a TPC file, which is a renamed zip archive, from the download page of the website. Once downloaded, they can be installed using the Install Export Templates option in the editor. Resource options. When exporting, Godot makes a list of all the files to export and then creates the package. There are 5 different modes for exporting. Export all resources in the project, export selected scenes and dependencies, export selected resources and dependencies, export all resources in the project except resources checked below, export as dedicated server. Export all resources in the project will export every resource in the project. Export selected scenes and export selected resources gives you a list of the scenes or resources in the project, and you have to select every scene or resource you want to export. Export all resources in the project except resources checked below does exactly what it says. Everything will be exported except for what you select in the list. Export was dedicated server will remove all visuals from a project and replace them with a placeholder. This includes cube map array, material, mesh, texture 2D, texture 2D array, texture 3D. You can also go into the list of files and specify specific visual resources that you do wish to keep. Note: the files and folders whose name begins with a period will never be included in the exported project. This is done to prevent version control folders like the .git from being included in the exported package PCK file. Below the list of resources are 2 filters that can be set up. The first allows non-resource files such as .text, .json, and .csv to be exported with the project. The second filter can be used to exclude every file of a certain type without manually deselecting every one. For example, .png files. Configuration files. The export configuration is stored in 2 files that can both be found in the project directory. Export presets.cfg. This file contains the vast majority of the export configuration can be safely committed to version control. There's nothing in here that you would normally have to keep secret. Godot export credentials.cfg. This file contains export options that are considered confidential, like passwords and encryption keys. It should generally not be committed to a version control or shared with others unless you know exactly what you are doing. Since the credentials file is usually kept out of version control systems, some export options will be missing if you clone the project to a new machine. The easiest way to deal with this is to copy the file manually from the old location to the new one, exporting from the command line. In production, it is useful to automate builds, and Godot supports this with the export release and export debug command line parameters. Export from the command line still requires an export preset to define the export parameters. A basic invocation of the command would be that. This will export to some name.exe, assuming there is a preset called Windows Desktop and the template can be found. The export preset name must be written within quotes if it contains spaces or special characters. The output path is relative to the project path or absolute. It does not respect the directory or the command was invoked from. The output file extension should match the one used by the Godot export process. Windows.exe, macOS.app, or .zip, or .damage or .dmg when exporting from macOS. Linux, any extension, including one. I don't need to worry about the rest of that. You can also configure it to export only one PCK or zip file, allowing a single exported main pack file to be used with multiple Godot executables. When doing so, the export preset name must still be specified on the command line. Godot export pack Windows Desktop assembly. It is often useful to combine the export release flag with the path flag so that you do not need to cd to the project folder before running the command. See also the command line tutorial for more information about using Godot from the command line. PCK versus zip pack file formats. Each format has its upsides and downsides. PCK is the default and recommended format for most use cases, but you may want to use a zip archive instead of depending on your needs. PCK format. Uncompressed format, larger file size, but faster to read or write. Not readable and writable using tools normally present on the user's operating system, even though there are third-party tools to extract and create PCK files. Zip format. Compressed format, smaller file size, but slower to read or write. Readable and writable using tools normally present on the user's operating system. This can be useful to make modding easier. See also exporting packs, patches, and mods. Warning: due to known bug when using zip file as pack file, the exported binary will will not try to use it automatically. Therefore, you have to create a launcher script that the player can double-click or run from a terminal to launch the project. Save the launcher script and place it in the same folder as the exported binary. On Linux, make sure to give executable permissions to the launcher script using the command chmod. How long are we into the stream? 2 hours? Okay. Let's see. What all do we have left? 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then there are also the engine details, community, and class references. But right now, the manual... Yeah. Okay. I'll be back. I have to go talk with my sister about things. Have fun with the music. Sorry I was gone for so long. I was talking to my sister about designing some characters for me for the game. Uh, let's see. Has anything happened on Discord? No, not really. Okay. Alright, exporting packs, patches, and mods. Use cases. Oftentimes, one would like to add functionality to one's game after it has been deployed. Examples of this include downloadable content, the ability to add features and content to one's game. Patches, the ability to fix a bug that is present in a shipped product. Mods, grant other people the ability to create content for one's game. These tools help developers extend their development beyond the initial release. Um, use cases. Oftentimes one would like to add functionality, patches. These tools often help developers extend their development beyond the initial release. Overview of the PCK or zip files. Godot enables uh, okay. Uh, Overview of PCK or zip files. Godot enables this via a feature called resource packs. PCK files with the PCK extension or zip files. Advantages: incremental updates or patches. Offers DLCs, offer mod support, no source code disclosure needed for mods, or modular project structure. Users don't have to replace the entire game. The first part of using them involves exporting and delivering the project to players. Then, when one wants to add functionality or content later on, they just deliver the updates via PCK or zip files to the users. PCK files usually contain, but are not limited to, scripts, scenes, shaders, models, textures, sound effects, music, any other asset suitable for import into the game. The PCK or zip files can be an entirely different Godot project, which the original game loads in at runtime. It is possible to load both PCK and zip files as additional packs at the same time. See PCK versus zip pack file formats for comparison of the two formats. See also, if you want to load loose files at runtime, not packed in a PCK or zip by Godot, consider using runtime file loading and saving instead. This is useful for loading user-generated content that is not made with Godot, without requiring users to pack their mods into a specific file format. The downside of this approach is that it's less transparent to the game logic, and as it will not benefit from the game resource management as PCK or zip files. Generating PCK files. In order to pack all resources of a project into a PCK file, open the project and go to Project, Export, and click on the Export PCK or zip. Also, make sure to have an export preset selected while doing so. Another method would be to export from the command line with export pack. The output file must with a .pck or .zip file extension. The export process will build that type of file for the chosen platform. Note, if one wishes to support mods for their game, they will need users to create similarly exported files, assuming the original game expects a certain structure for the PCK's resources and/or certain interface for its scripts, then either. The developer must publicize documentation of these expected structures, interfaces, expect modders to install Godot Engine, and then also expect those modders to conform to the documentation's defined API when building mod content for the game. See that it will work. Users would then use Godot's built-in exporting tool to create a PCK file, as detailed above. The developer uses Godot to build a GUI tool for adding their exact API content to a project. This Godot tool must either run on a tools-enabled build of the engine or have access to one, distributed alongside or perhaps in the original game's files. The tool can then use the Godot executable to export a PCK file from the command line with OS execute. The game itself shouldn't use a tool build of the engine for security, so it's best to keep the modding tool and game separate. Opening PCK or zip files at runtime. To load a PCK or zip file, one uses the project settings singleton. The following example expects a mod.pck file in the directory of the game's executable. The PCK or zip file contains a mod scene or .tscn test scene in its root. Warning, by default, if you import a file with the same file path or name as one you already have in your project, the imported one will replace it. This is something to watch out for when creating DLC or mods. You can solve this problem by using a tool that isolates mods to a specific mod subfolder. However, it is also a way of creating patches for one's own game. A PCK or zip file of this kind can fix the content of a previously loaded PCK or zip. Therefore, the order in which packs are loaded matters. To opt out of this behavior, pass false as the second argument to project settings.load resource pack. Note, for a C# project, you need to build the DLL and place it in the project directory first. Then, before loading the resource pack, you need to load its DLL as follows: assembly.loadfile mod.dll. Troubleshooting. If you are loading a resource pack and are not noticing any changes, it may be due to the pack being loaded too late. This is particularly the case when with menu scenes that may preload other scenes using preload. This means that loading a pack in the menu will not affect the other scene that was already preloaded. To avoid this, you need to load the pack as early as possible. To do so, create a new autoload script and call project settings.load resource pack. In the autoload script, init function rather than entry tree or ready. Summary: this tutorial explains how to add mods, patches, or DLC to a game. The most important thing is to identify how one plans to distribute future content for their game and develop a workflow that is customized for that purpose. Godot should make that process smooth regardless of which route a developer pursues. Feature tags. Introduction. Godot has a special system to tag availability of features. Each feature is represented as a string which can refer to many of the following: platform name, platform architecture, platform type, supported texture compression algorithms on the platform, whether a build is debug or release. Debug includes the editor, whether the project is running from the editor or a standalone binary, many more things. Features can be queried at runtime from the singleton API by calling OS has feature name. OS feature tags are used by GD extension to determine which libraries to load. For example, a library for Linux debug editor will be loaded only using a debug editor build for Linux. That. Default features. Here's a list of most features, feature tags in Godot. Keep in mind they are case sensitive. Damn. Warning, with the exception of texture compression, web platform, and movie feature tags, default feature tags are immutable. This means that they will not change depending on runtime conditions. For example, OS has feature mobile will return false when running a project exported to web on a mobile device. To check whether a project exported to web is running on a mobile device, use OS has feature web Android or OS has feature web iOS. Custom features. It is possible to add custom features to a build. Use the relevant field in the export preset used to generate it. Note, custom feature tags are only used when running the exported project, including with one-click deploy. They are not used when running the project from the editor, even if the export preset marked as runnable for your current platform has custom feature tags defined. Custom feature tags are also not used in editor export plugin scripts. Instead, feature tags in editor export plugin will reflect the editor the device is currently running on. Overriding project settings. Features can be used to override specific configuration values in the project settings. This allows you to better customize any configuration when doing a build. In the following example, a different icon is added for the demo build of a game, which was customized in a special export preset, which in turn includes only demo levels. The desired after overriding, a new field is added in the specified configuration. Note, when using the project settings override configuration functionality, which is unrelated to feature tags, remember that feature tags still apply. Therefore, make sure to also override the setting with the desired feature tags if you want them to override base project settings on all platforms and configurations. Default overrides. There are already a lot of settings that come with overrides by default. They can be found in many sections of the project settings. Taking feature tags into account when rating project settings. By default, feature tags are not taken into account when rating project settings using the typical approaches. Instead, you must use project settings.getSetting with override. For example, with the following project settings. Using project settings.getSetting will return release regardless of whether a debug build is currently running. On the other hand, project settings.getSetting with override will obey feature tags and will return debug if using a debug build. Customizing the build. Feature tags can be used to customize a build process too by writing a custom export plugin. They are also used to specify which shared library is loaded and exported in GD extension. Exporting for Windows. See also. This page describes how to export a Godot project to Windows. If you're looking to compile editor or export template binaries from source instead, read Compiling for Windows. The simplest way to distribute a game for PC is to copy the executable godot.exe, compress the folder and send it to someone else. However, this is often not desired. Godot offers a more elegant approach for PC distribution when using the export system. When exporting for Windows, the exporter takes all the project files and creates a data.pack file. This file is bundled with a specially optimized binary that is smaller, faster, and does not contain the editor and debugger. Architecture. There are 3 different processor architectures that exported Godot projects can run on in Windows. The default x86-64 is the most common architecture of PC processors today. All modern Intel and AMD processors as of writing this are x86-64. x86-32 will give you a 32-bit executable that can run on 32-bit only versions of Windows, as well as modern versions which are 64-bit. It is not recommended to use this option unless you're trying to get your project to run on an old 32-bit version of Windows. And it should be noted that no 32-bit versions of Windows receive Microsoft support anymore. ARM64 processors are modern but less common than x86-64 and run Windows on ARM. Snapdragon X Elite is an example of a modern Windows ARM processor. Using this export option will allow your project to run natively on ARM processors without Microsoft's Prism emulator. Executables made using this option will not run on a regular Windows with 86-64 processor. If you're uploading your project to a platform that allows multiple executables such as itch.io and are confident a Snapdragon Elite processor is powerful enough to run it, we would recommend providing an ARM version. Prism Emulator is far from perfect, and Godot does not require you to build or design your game in any special way to run on ARM. Changing the executable icon. Godot will automatically use whatever image is set as your project's icon in the project settings, and convert it to an ICO file for the exported project. If you want to manually create an ICO file for greater control over how the icon looks at different resolutions, then see the manually changing application icon for Windows page. PCK embedding. PCK embedding is only supported on executables up to 3.89 gigabytes in size. This metric includes both the executable and embedded PCK size, so in practice the PCK file may only weigh up to around 3.75 gigabytes. This can also vary depending on build options when using a custom export template. Code signing. Godot is capable of automatic code signing on export. To do this, you must have the Windows SDK on Windows or OSL sign code or any other OS installed. You will also need a package signing certificate informing information on creating one can be found here. Setup. Settings need to be changed in two places. First, in the editor, under Export Windows, click on the folder next to the Sign Tool setting. If you're using Windows, navigate to the Select Sign Tool.exe. If you're on a different OS, select OS SL sign code. The second location is the Windows Export preset, which can be found in Project Export, and Windows Desktop preset if you haven't already. Under Options, there's a code signing category. Enabled must be set to true, and Identify must be set to signing certificate. The other settings can be adjusted as needed. Once this is done, Godot will sign your project on export. Environment variables. You can use the following environment variables to set export options outside the editor. During the export process, these override the values that you set in the export menu. Export options. You can find a full list of export options available in the editor export platform Windows class reference. Exporting for Linux, for Mac OS, for Android, for iOS, Vision OS, exporting for the web, manually changing application icon for Windows. Windows applications use a Windows-only format called ICO for their file icon and taskbar icon. Since Godot 4.1, Godot can create an ICO file for you based on the icon file defined in the Windows export preset. Supported formats are PNG, WebP, and SVG. If no icon is defined in the Windows export preset, the application config icon project setting is used automatically instead. This means you no longer need to follow the steps in this section to manually create an ICO file, unless you wish to have control over the icon design depending on its displayed size. Creating a custom ICO file. You can create your application icon in any program, but will need to convert it to an ICO file using a program such as GIMP. This video tutorial goes over how to export an ICO file with GIMP. It is also possible to convert a PNG image to an HIDPI-friendly ICO file using the ImageMagick command. Depending on which version of ImageMagick you installed, you might need to leave out the magic and run this command instead. Warning: for the ICO file to effectively replace the default Godot icon, it must contain all the sizes, including the default Godot icon 16x16, 32x32, 48x48, 64x64, 128x128, 256x256. If the ICO file does not contain all the sizes, the default Godot icon will be kept for the sizes that weren't overridden. The above ImageMagick command takes this into account. Changing the taskbar icon. Taskbar icon is the icon that shows up on the taskbar when your project is running. To change the taskbar icon, go to Project, Project Settings, Application Config. Make sure and advanced settings are enabled to see this setting. Then go to Windows Native icon, click on the folder icon, and select your ICO file. This setting only changes the icon for your exported game on Windows. To set the icon for macOS, use macOS native icon, and for any other platform, use the icon setting. Changing the file icon. The icon is the icon of the executable that you click on to start the project. To do that, you'll need to specify the icon when exporting. Go to Export Project, assuming you have already created a Windows desktop preset. Select your icon in ICO format in the application icon field. Testing the result. You can now export the project. If it worked correctly, you should see this. Note, if your icon isn't showing up properly, try clearing the icon cache. To do so, open the Run dialog and enter that or that. Running Godot apps on Mac OS. Android. Don't need to worry about Mac OS. I'm not on a Mac. And don't need that for Android. One-click deploy. What is one-click deploy? One-click deploy is a feature that is available once a platform is properly configured and supported devices connected to the computer. Since things can go wrong at many levels, platform may not be configured correctly, SDK may be incorrectly installed, device may be improperly configured, etc. It's good to let the user know that it exists. After adding an Android export preset marked as runnable, Godot can detect when a USB device is connected to the computer and offer the user to automatically export, install, and run the project in debug mode on the device. This feature is called one-click deploy. It is only available once you added an export template marked as runnable in the export dialog. You can mark several export presets as runnable, but only one preset per platform may be marked as runnable. If you mark a second preset in a given platform as runnable, the other preset will no longer be marked as runnable. Supported platforms: Android, iOS. Desktop platforms exports the project with debugging enabled and runs it on remote computer via SSH. Using one-click deploy. Android, iOS, desktop platforms. Enable SSH remote deploy and configure connection setting in the project export settings. Make sure there is an export preset marker as a runnable for the target platform, Android, iOS, or web. If everything is configured correctly and with no errors, platform-specific icons will appear in the top right corner of the editor. Click the button to export the desired platform in one click. Troubleshooting: Android, web. Just web, okay. Exporting for dedicated servers. If you want to run a dedicated server for your project on a machine that doesn't have a GPU or a display server available, you'll need to run Godot with the headless display server and dummy audio driver. Since Godot 4.0, this can be done by running a Godot binary on any platform with the headless command line argument, or running a project exported as a dedicated server. You do not need to use a specialized server binary anymore, unlike Godot 3.x. Editor versus export template. It's possible to use either an editor or export template, debug or release a binary in headless mode. Which one you should use depends on your case. Export template. Use this one for running dedicated servers. It does not contain editor functionality and is therefore smaller and more optimized. Editor. This binary contains editor functionality and is intended to be used for exporting projects. This binary can be used to run dedicated servers, but it's not recommended as it's large and less optimized. Export approaches. There are two ways to export a project for a server. Create a separate export preset for the platform that will host the server, then export your project as usual. Export a PCK file only, preferably for the platform that matches the platform that will host the server. Place the PCK file in the same folder as an export template binary. I don't think I'm going to be using dedicated servers. Yeah, file data and I/O. Background loading. Commonly, games need to load resources asynchronously. When switching the main scene of your game, e.g. example, going to a new level, you might want to show a loading screen with some indication that progress is being made, or you might want to load additional resources during gameplay. The standard load method, resource_loader.load, or ddScript simpler load, blocks your thread, making your game appear unresponsive while the resource is being loaded. One way around this is using resource loader to load resources asynchronously in background threads. Using resource loader, generally your queue you queue requests to load resources for a path using resource loader.load threaded request, which will then be loaded in threads in the background. You can check the status with resource loader.load threaded get status. Progress can be obtained by passing an array variable via progress, which will return a one-element array containing the percentage. Finally, you retrieve loaded resources by calling resource loader load threaded get. Once you call load threaded get, either the resource finished loading in the background will be returned instantly, or the load will block at this point like load would. If you want to guarantee this does not block, you either need to ensure there is enough time between requesting to load and retrieving the resource, or you need to check the status manually. Example. This example demonstrates how to load a scene in the background. We will have a button spawn on an enemy when pressed. The enemy will be enemy.tscn, which will load on ready and instantiate when pressed. The path will be enemy.tscn, which is located at that. First, we will start a request to load the resource and connect the button. Now on button pressed will be called when the button is pressed. This method will be used to spawn an enemy. File paths in Godot projects. This page explains how file paths work inside Godot projects. You will learn how to access paths in your project using res and user notations, and where Godot stores project and editor files on your and your user's systems. Path separators. To make supporting multiple platforms easier, Godot uses Unix-style path separators / these work on all platforms, including Windows. Instead of writing paths like projects game in Godot, you should write projects game. Windows-style path separators / are also supported in some path-related methods, but they need to be doubled, as / is normally used an escape for characters with special meaning. This makes it possible to work with paths returned by other Windows applications. We still recommend using only / in your own code to guarantee that everything will work as intended. Tip: the string class offers over a dozen methods to work with strings that represent file paths. Accessing files in project folder. Godot considers that a project exists in any folder that contains a project.godot text file. Even if the file is empty, the folder that contains this file is your project's root folder. You can access any file relative to it by writing paths starting with res, which stands for resources. For example, you can access an image file, character.png, located in the project's root folder in code, with the following path: accessing persistent user data. To store persistent data files, like the player save or settings, you want to use user instead of res as your path's prefix. This is because when the game is running, the project file system will likely be read-only. The user prefix points to a different directory on the user's game device. Unlike res, the directory pointed at by user is created automatically and guaranteed to be writable to, even in an exported project. The location of the user folder depends on what is configured in the project settings. By default, the user folder is created within Godot's editor data path in the app user data project name folder. This is the default so that prototypes and test projects stay self-contained within Godot's data folder. If applications as config/use custom user dir is enabled in the project settings, the user folder is created next to Godot's editor path, i.e. in the standard location for applications data. By default, the folder name will be inferred from the project name, but it can be further customized with application config custom user dir name. This path can contain path separators, so you can use it, example, to group projects to a given audio with a studio name, game name structure. On desktop platforms, the actual directory path for user are all those. Project name is based on the application name defined in the project settings, but you can override it on a per platform basis using feature tags. On mobile platforms, this path is unique to the project and is not accessible by other applications for security reasons. On HTML5 exports, user will refer to a virtual file system stored on the device via index DB. Interaction with the main file system can be performed through the JavaScript bridge singleton. File logging. See also documentation on file logging has been moved to logging. Converting paths to absolute paths or local paths. You can use project settings, globalize path, to convert a local path like res path to file.txt to an absolute OS path. For example, project setting globalize path can be used to open local paths in the OS file manager using OS shell open, since it only accepts native OS paths. To convert an absolute OS path to a local path starting with res or user, use project settings localize path. This only works for absolute paths that point to files or folders in your project's root or user folders. Editor data paths. The editor uses different paths for editor data, editor settings, and cache depending on the platform. By default, these paths are those. Editor data contains export templates and project-specific data. Editor settings contains main editor setting configurations file as well as various other user-specific customizations. Editor layouts, feature profiles, script templates, etc. Cache contains data generated by the editor or stored temporarily. It can safely be removed when Godot is closed. Godot compiles with the XDG base directory specification. On Linux BSD, you can override the XDG data home, XDG config home, and XDG cache home environmental variables to change the editor and project data paths. Note, if you use Godot packaged as Flatpak, the editor data path will be located in subfolders in that. Self-contained mode. If you create a file called SC or SC, the same directory as the path binary, or in macOS contents or macOS editor or .app bundle, Godot will enable self-contained mode. This mode makes Godot write all editor data settings and cache it to a directory named editor data in the same directory as the editor binary. You can use it to create a portable installation of the editor. The Steam release of Godot uses self-contained mode by default. Note, self-contained mode is not supported in exported projects yet. To read and write files relative to the executable path, use OS get executable path. Note that writing files in the executable path only works if the executable is placed in a writable location, i.e. not program files or another directory that is read-only for regular users. Saving games. Introduction. Save games can be complicated. For example, it may be desirable to store information for multiple objects across multiple levels. Advanced save game systems should allow for additional information about an arbitrary number of objects. This will allow the save function to scale as the game grows more complex. Note, if you're looking to save user configuration, you can use the config file class for this purpose. You can see how saving and loading works in action using the Saving and Loading Serialization demo project. Identify persistent objects. Firstly, we should identify what objects we want to keep between game sessions and what information we want to keep from those objects. For this tutorial, we will use groups to mark and handle objects to be saved, but other motions are certainly possible. I'm just gonna close this. Don't save. We will start by adding objects we wish to save to the persist group. We can do this through either GUI or script. Let's add the relevant nodes using the GUI. Once this is done, we need to save the game. We can get all objects to save them and then tell them all to save with the script. Serializing. The next step is to serialize the data. This makes it much easier to read from and store to disk. In this case, we're assuming each member of group persist is an instance code, and thus has a path. GDScript has the helper class JSON to convert between dictionary and string. Our node needs to contain a save function that returns this data. The save function will look like this. This gives us a dictionary with the style variable name value variable, which will be useful when loading, saving, and reading data. As covered in the file system tutorial, we need to open a file so we can write to it or read from it. Now that we have a way to call our groups and get their relevant data, let's use the class JSON to convert it into an easily stored string and store them in a file. Doing it this way ensures that each line is its own object, so we can have an easy way to pull the data out from the file as well. Game saved. Now to load, we'll read each line. Use the parse method to read the JSON string back to a dictionary, and then iterate over the dictionary read our values. But we'll need to first create the object, and we can use the file name and parent values to achieve that. Here's our load functions. Now we can save and load an arbitrary number of objects laid out almost anywhere across the scene tree. Each object can store different data depending on what it needs to save. Some notes. We have glossed over setting up the game state for loading. It's ultimately up to the project creator where much of this logic goes. This is often complicated and will need to be heavily customized based on the needs of the individual project. Additionally, our implementation assumes no persist objects are children of other persist objects. Otherwise, invalid paths would be created. To accommodate nested persist objects, consider saving objects in stages. Load parent. Hi, Shelby. Come here. Shelby, come here. Hi. Where was I? Where much of this logic goes. This is often complicated and will need to be heavily customized based on the needs of the individual product. Additionally, our implementation assumes no persist objects are children of other persist objects. Otherwise, invalid paths would be created. To accommodate nested persist objects, consider saving objects in stages. Load parent objects first so they are available for the add child call when child objects are loaded. You'll also need a way to link children to parents, as the node path will likely be invalid. JSON versus binary serialization. For simple game state, JSON may work and it generates human-readable files that are easy to debug. But JSON has many limitations. If you need to store more complex game state, or a lot of it, binary serialization may be much better. Maybe a better approach. Bleh. JSON limitations. Here are some important gotchas to know about when using JSON. File size. JSON stores data in text format, which is much larger than binary formats. Data types. JSON only offers a limited set of data types. If you have data types that JSON doesn't have, you will need to translate your data to and from that type that JSON can handle. For example, some important types that JSON can't parse are vector2, vector3, color, rect2, and quaternion. Custom logic needed for encoding or decoding. If you have any custom classes that you want to store with JSON, you will need to write your own logic for encoding and decoding those classes. Binary serialization. Binary serialization is an alternative approach for storing game data, for game state. For storing game state, you can use it while the functions get variable and store variable of file access. Binary serialization should produce smaller files than JSON. Binary serialization can handle most common data types. Binary serialization requires less custom logic for encoding and decoding custom classes. Note that not all properties are included. Only properties that are configured with the property usage storage flag will be serialized. You can add a new usage flag to a property by overriding the getPropertyList method in your class. You can also check how property usage is configured by calling object getPropertyList. See property usage flags for possible usage flags. Runtime file loading and saving. See saving games for information on saving and loading game progression. Sometimes exporting packs, patches, and mods is not ideal when you want players to be able to load user-generated content in your project. It requires users to generate a PCK or zip file through the Godot editor, which contains resources imported by Godot. Example use cases for runtime file loading and saving include loading texture packs designed for the game, loading user-provided audio tracks and playing them back in an in-game radio station, loading custom levels or 3D models that can be designed with any 3D DCC that can export to GLTF or FBX, including GLTF scenes saved by Godot at runtime. Using user-provided fonts for menus and HUD. Saving or loading a file format that can contain multiple files but can still easily be read by another application's zip. Loading files created by another game or program, or even game data files from another game not made with Godot. Runtime file loading can be combined with HTTP requests to load resources from the internet directly. Warning: do not use this runtime loading approach to load resources that are part of the project, as it's less efficient and doesn't allow benefiting from Godot's resource handling functionality, such as translation remaps. See import process for details. See also, you can see how saving and loading works in action using the runtime file saving and loading serialization demo projects. Plain text and binary files. Godot's file access class provides methods to access files on the file system for reading and writing. To handle custom binary formats, such as loading file formats not supported by Godot, file access provides several methods to read write integers, floats, strings, and more. These file access methods have names that start with get and store. If you need more control over reading binary files or need to read binary streams that are not part of a file, packed byte array provides several helper methods to decode or encode series of bytes to integers, floats, strings, and more. These packed byte array methods have names that start with decode and encode. See also binary serialization API. Images. Image load from file. Static method handles everything, from format detection based on file extension to reading the file from disk. If you need error handling or more control, such as changing the scale an SVG is loaded at, use one of the following methods depending on the file format. Several image formats can also be saved by Godot at runtime using the following methods. The methods file with the toBuffer suffix save the image to a packed byte array instead of the file system. This is useful to send the image over to the network or into a zip archive without having to write it on the file system. This can increase performance by reducing I/O utilization. Note, if displaying the loaded image on a 3D surface, make sure to call image.generate mipmap so that the texture doesn't look grainy when viewed at a distance. This is also useful in 2D when following instructions on reducing aliasing when downsampling. Example of loading an image and displaying it in a texture rec node, which requires conversion to image texture. Audio or video files. Godot supports loading OGG, Vorbis, MP3, and WAV audio at runtime. Note that not all files with a .ogg extension are OGG Vorbis files. Some may be OGG Theora videos or contain Opus audio within an OGG container. These files will not load correctly as audio files in Godot. Example of loading an OGG Vorbis audio file in an audio stream player node. Example of loading an OGG Theora video file in a video stream player node. 3D scenes. Godot has first-class support for GLTF 2.0 both in the editor and exported projects using GLTF document and GLTF state. Together, Godot can load and save GLTF files in exported projects in both text, GLTF, and binary, GLB formats. The binary format should be preferred as it's faster to write and smaller, but the text format is easier to debug. Since Godot 4.3, FBX scenes can also be loaded but not saved at runtime using the FBX document and FBX state classes. The code to do so is the same as GLTF, but you will need to replace all instances of GLTF document and GLTF state and FBX document and FBX state in the code samples below. Example of loading a GLTF scene and appending its root node to the scene. Note, when loading GLTF scene, a base path must be set so that external resources like textures can be loaded correctly. When loading from a file, the base path is automatically set to the folder containing the file. When loading from a buffer, this base path must be manually set as there is no way for Godot to infer this path. To set the base path, set GLTF state base path on your GLTF state instance before calling GLTF document append from buffer or GLTF document append from file. Fonts. Font file load dynamic font supports the following file formats: TTF, OTF, WOFF, WOFF2, PFB, PFM. On the other hand, font file load bitmap font supports a BMF font format, .fnt or .font. Additionally, it is possible to load any font that is installed on the system using Godot's support for system fonts. Example of loading a font automatically according to its file extension, then adding it as a theme override to a labeled node. Zip archives. Godot supports reading and writing zip archives using the zip reader and zip packer classes. This supports any zip file, including files generated by Godot's export PCK zip functionality, although these will contain imported Godot resources rather than the original project files. Note, use project settings load resource pack to load PCK or zip files exported by Godot as additional data packs. That approach is preferred for DLCs as it makes interacting with additional data packs seamless. Virtual file system. This zip archive support can be combined with runtime image 3D, scene, and audio loading to provide a seamless modding experience without requiring users to go through the Godot editor to generate PCKs or zip files. Example that lists files in a zip archive in the item list mode, then writes contents read from it to a new zip archive, essentially duplicating the archive. Work in progress. Binary Serialization API. Introduction. Godot has serialization API based on variant. It's used for converting data types to an array of bytes efficiently. This API is exposed via the global bytes to var and var to bytes functions, but it is also used to get var and store var methods of file access, as well as the packet APIs for packet peer. This format is not used for binary scenes and resources. Full objects versus object instance IDs. If a variable is serialized with full objects equals true, then any objects contained in the variable will be serialized and included in the result. This is recursive. If full objects equals false, then only the instance IDs will be serialized for any objects contained in the variable. Packet specification. Packet is designed to be always padded to 4 bytes. All values are little endian encoded. All packets have a 4-byte header representing an integer specifying the type of data. The lowest value 2 bytes are used to determine the type, while the highest value 2 bytes contain flags. Following this, the actual packet contents, which varies for each type of packet. Note that this assumes Godot is compiled with single precision floats, which is the default. If Godot is compiled with double precision floats, the length of float fields within data structure should be 8. The offset should be offset -4 times 2 plus 4. The float type itself always uses double precision. If no flags are set, flags equal 0, the integer is sent as a 32-bit integer. If flag encode flag 64 is set, flags and 1 equals 1, the integer is sent as a 64-bit integer. Float, string, vector, rect, all this bullshit. Padded for 4 bytes for new format for each name and subname. Every name string is padded to 4 bytes, 16-bit unsupported object. An object could be serialized in different ways as a null value with full objects equals false, or with full objects equals true. Null value, full objects disabled, full objects enabled for each property. Note, not all properties are included. Only properties that are configured with the property usage storage flag set must be will be serialized. Flag set will be serialized. You can add a new usage flag to a property by overriding the getPropertyList method in your class. You can also check how property usage is configured by calling object getPropertyList. See property usage flags for possible usage flags. Dictionary. Then what follows is for amount of elements, pairs of key and values, one after the other using this same format. 19 array. Then what follows is for amount of elements, values, one after the other using this format. 20 packaged byte array. The array data is padded to 4 bytes. Packaged int 32 array. Packaged int 64 array. Packaged float 32 array. Packaged float 64 array. Packaged string array. For each string, every string is padded to 4 bytes. Packaged vector 2 array. Packaged vector 3 array. Packaged color array. Alright, next section, internationalization. Lovely. Lovely. Alright. I'm gonna use the bathroom. I shall be right back. And we may continue. Alright. Internationalization. I'm not sure if I'm going to be not sure when I'm going to be doing this, but internationalizing games. Introduction. While indie or niche games usually do not need localization, games targeting a more massive market often require localization. Godot offers many tools to make this process more straightforward, so this tutorial is more like a collection of tips and tricks. Localization is usually done by specific studios hired for the job, despite the huge amount of software and file formats available for this. The most common way to do localization to this day is still with spreadsheets. The process of creating the spreadsheets and importing them is already covered in the Importing Translations tutorial. If you haven't read the Importing Translations page before, we recommend you give it a read before reading this page. Note, we will be using the official demo as an example. You can download it from the asset library. Configuring the important translation. Translations can be updated and re-imported when they change, but they still have to be added to the project. This is done in project settings, localization, translations. The above dialog is used to add or remove translations project-wide. Localizing resources. It can also be possible to instruct Godot to use alternate versions of assets, resources, depending on the current language. This can be used for localizing images such as in-game billboards or localized voices. The Remaps tab can be used for this. Select the resource to be remapped, then add some alternatives for its locale. Note, the resource remapping system isn't supported for dynamic fonts. To use different fonts depending on the language's script, use the dynamic font fallback system instead, which lets you define as many fallback fonts as you want. The upside of the dynamic font fallback system is that it works regardless of the current language, making it ideal for things like multiplayer chat where the text language may not match the client's language. Automatically setting a language. It is recommended to default to the user's preferred language, which can be obtained via OS get locale language. If your game is not available in that language, it will fall back to the fallback in project settings, general internationalization, locale, or to EN if empty. Nevertheless, letting players change the language in-game is recommended for various reasons. Example, translation quality or player preference. Locale versus language. A locale is commonly a combination of language with a region or country, but can also contain information like a script or a variant. Examples: English language, English in Great Britain, British English, English in the USA, American English, English in Germany. Indie games usually only need to care about language, but read on for more information. Why locales exist can be illustrated through the USA and Great Britain. Both speak the same language, English, yet differ in many aspects. Spelling, example, gray, USA, gray, Great Britain. Use of words, example, eggplant, USA, aubergine, Great Britain. Units or currencies, example, feet or inches, USA, meters or centimeters, Great Britain. It can get more complex, however. Imagine you offer different content in Europe and in China, example in an MMO. You will need to translate each of those content variations into many languages and store and load them accordingly, converting keys to text. Some controls such as button and label will automatically fetch a translation if their text matches a translation key. For example, if a label's text is main screen greeting 1 and that key exists in the current translation, then the text will automatically be translated. This automatic translation behavior may be undesirable in certain cases. For instance, when using a label to display a player's name, you most likely don't want the player's name to be translated if it matches a translation key. To disable automatic translation on a specific node, set the auto-translate mode to disabled in the inspector. In code, the object.tr function can be used. This will just look up the text and the translations and convert it if found. Note, if no text is displayed after changing the language, try to use a different font. The default project font only supports a subset of Latin 1 character set, which cannot be used to display languages like Russian or Chinese. A good resource for multilingual fonts is Noto fonts. Make sure to download the correct variation if you're using a less common language. Once you've downloaded the font, load the TTF file into a dynamic font resource and use it as a custom font of your control node. For better reusability, associate a new theme resource to your root control node and define the dynamic font as the default font in the theme. Placeholders. To feature placeholders in your translated strings, use the GDScript format strings, or the equivalent feature in C#. This lets translators move the location of the placeholder in the string freely, which allows translation to sound more natural. Named placeholders with the string format function should be used whenever possible. They also allow translators to choose the order in which placeholders appear. I'm looking at this. It's rather short because we got internationalizing games. This section is long. Localizing using spreadsheets, localizing using get text, profiles, locale codes, and pseudo-localization. Translation context. If you're using plain English as source strings rather than message codes like this, you may run into ambiguities when you have to translate the same English string to different strings in certain target languages. You can optionally specify a translation context to resolve this ambiguity and allow target languages to use different strings, even though the source string is identical. Pluralization. Most languages require different strings depending on whether an object is in singular or plural form. However, hard-coding the is plural condition depending on whether there is more than one object is not valid in all languages. Some languages have more than 2 plural forms, and the rules on the number of objects required for each plural form vary. Godot offers support for pluralization so that the target locales can handle this automatically. Pluralization is meant to be used with positive or 0 integer numbers only. Negative and floating point values usually represent physical entities for which singular and plural don't clearly apply. This can be combined with a context if needed. Making controls resizable. The same text in different languages can vary greatly in length. For this, make sure to read the tutorial on size and anchors, as dynamically adjusting control sizes may help. Container can be useful, as well as the text wrapping options available in Label. To check whether your UI can accommodate translations with longer strings than the original, you can enable pseudo-localization in the advanced project settings. This will replace all your localizable strings with longer versions of themselves, while also replacing some characters in the original strings with accented versions, while still being readable. Placeholders are kept as is so that they keep working when pseudo-localization is enabled. For example, the string hello world, this is ampersand S exclamation mark becomes hello world. This is when pseudo-localization is enabled. While looking strange at first, pseudo-localization has several benefits. It lets you spot Hello, Bella. It lets you spot known localizable strings quickly, so you can go over them and make them localizable, if it makes sense to do so. It lets you check UI elements that can't fit long strings. Many languages will feature much longer translations than the source text, so it's important to ensure your UI can accommodate longer than usual strings. It lets you check whether your font contains all the characters required to support various languages. However, since the goal of pseudo-localization is to keep the original string readable, it is not effective to test for checking whether a font can support CJK or right-to-left languages. The project settings allow you to tune pseudo-localization behavior so that you can disable parts of it if desired. Translation server. Godot has a server handling low-level translation management called the translation server. Translations can be added or removed during runtime. The current language can also be changed at runtime. Bidirectional text and UI mirroring. Arabic and Hebrew are written from left to right, or right to left, except for the numbers and Latin words mixed in, and the user interface for these languages should be mirrored as well. In some languages, the shape of a glyph changes depending on the surrounding characters. Support for bidirectional writing systems and UI mirroring is transparent. You don't usually need to change anything or have any knowledge of the specific writing system. For RTL languages, Godot will automatically do the following changes to the UI. Mirrors left or right anchors and margins, swaps left and right text alignment, mirrors horizontal order of the child controls in the containers, and items in tree item list controls. Uses mirrored order in the internal control elements. Example, option button, drop down button, checkbox, check button, alignment, list column order, tree item icons, and connecting line alignment. In some cases, mirrored controls use separate theme styles. Coordinate system is not mirrored. Non-UI nodes, sprites, etc. are not affected. It is possible to override text and control layout direction by using the following control properties. Text direction sets the base text direction. When set to auto, the direction depends on the first strong directional character in the text according to the Unicode bidirectional algorithm. Language overrides the current project locale. The structured text BIDI override property and structured text parser callback enable special handling for structured text. Layout direction overrides control mirroring. See also, you can see how right to left typesetting works in action by using the BIDI and font features demo project. Adding break iterator data to export a project. Some languages are written without spaces. In those languages, the word and line breaking require more than rules over character sequences. Godot includes ICU rule and dictionary-based break iterator data, but this data is not included in exported projects by default. To include it, go to Project Settings, General Internationalization, Locale, and enable Include Text Server Data, and then export the project. Break iterator data is about 4 megabytes in size. Structured text BIDI override. Unicode BIDI algorithm is designed to work with natural text, and it's incapable of handling text with the higher level order, like file names, URIs, email addresses, regular text expressions, and source code. For example, the path for this shown directory structure will be displayed incorrectly. Top line edit control. File type structured text override splits into text segment splits text into segments. Then BIDI algorithm is applied to each of them individually to correctly display directory names in any language and preserve correct order of the folder's bottom line edit control. Custom callbacks provide a way to override BIDI for the other types of structured text. Localizing numbers. Controls specifically designed for number input or output. Example, progress bar, spin box will use localized numbering system automatically for the other control. Text server format number string language can be used to convert Western Arabic numbers 0 to 9 to the localized numbering system and text parser. A text server parse number string language to convert it back. Localizing icons and images. Hello. You need something?
No.
Okay. How's it going, by the way?
I've written a lot of stuff down.
You've written a lot of stuff down?
Specifically one color.
What color?
The first color.
Black?
Yeah.
Okay. Yeah, so, I don't know if you understand, but everybody's going to be based off of black, and there will be, subcolors, right? Which can be any two combinations of colors. So black and green, but you can't have black and black, of course, because that's just going to be black. So black. Or green and red, so on and so forth.
Yeah.
Does that make sense?
Yeah.
Okay. Also, I suggest looking up stuff, see what other people think different colors represent, and then just write how you think these colors, what you think these colors represent in your own mind.
I wrote a lot of stuff down. I don't know if I put it.
You don't have to write it down all at once.
I already wrote down a lot of stuff.
Okay, that's fine. Localizing icons and image. Whatever you wrote is probably valid. Localizing icons and images. Icons with left and right pointing arrows, which may need to be reversed for Arabic and Hebrew locales, in case they indicate movement or direction. Example, back, forward buttons. Otherwise, they can remain the same. Testing translations. You may want to test a project's translation before releasing it. Godot provides 3 ways to do this. Under Project, Project Settings, General Internationalizations, Locale. With advanced settings enabled is a test property. Set this property to the locale code of the language you want to test. Godot will run the project with that locale when the project is run, either from the editor or when exported. Keep in mind that since this is the project setting, it will show up in version control when it is a non-canon empty value. Therefore, it should be set back to an empty value before committing changes to version control. Second, from within the editor, go to the top bar and click on View on the top bar. Then go down to Preview Translation and select the language you want to preview. All text in the scenes in the editor should now display using the selected language. Translations can also be tested when running Godot from the command line. For example, to test a game in French, the following argument can be supplied. Translating the project name. The project name becomes the app name when exporting to different operating systems and platforms. To specify the project name in more than one language, go to Project, Project Settings, General Application Config. From here, click the localization string size 0 button, then add translation button. It will take you to a page where you can choose the language and country if needed for your project name translation. After doing that, you can now type in the localized name. If you are unsure about the language code to use, refer to list of locale codes. Localization using spreadsheets. Spreadsheets are one of the most common formats for localizing games. In Godot, spreadsheets are supported through the CSV format. This guide explains how to work with CSVs. The CSV files must be saved with UTF-8, encoding without a byte order mark. Warning, by default, Microsoft Excel will always save CSV files with ANSI encoding rather than UTF-8. There is no built-in way to do this, but there are workarounds as described here. We recommend using LibreOffice or Google Sheets instead. Formatting. CSV files must be formatted as follows. The lang... Interesting. Car horn going out there. The lang tags must represent a language, which must be one of the valid locales supported by the engine, or they must start with an underscore, which means the related column is served as comment and won't be imported. The key tags must be unique and represent a string universally. By convention, these are usually in uppercase to differentiate them from other strings. These keys will be replaced at runtime by the matching translated string. Note that the case is important. Key 1 and key 1 will be different keys. The top left cell is ignored and can be left empty or having any content. Here's an example. The same example is shown below as a comma separating plain text file, which should be the result of editing the above in a spreadsheet. When editing the plain text version, be sure to enclose with double quotes any message that contains commas. The line breaks or double quotes so that commas are not parsed as delimiters. Line breaks don't create new entries, and double quotes are not parsed as enclosing characters. Be sure to escape any double quotes and message they may contain by preceding them with another double quote. Alternatively, you can select another delimiter, then comma in the import options. Specifying plural forms. Since Godot 4.6, it is possible to specify plural forms in CSV files. This is done by adding a column named plural anywhere in the table, except in the first column, which is reserved for translation keys. By convention, it is recommended to place it on the second column. Note that in the example below, the column is the one that contains English localization. Note, automatic control translation is not supported when using plural forms. You must translate the string manually using trn. Specifying translation context. Since Godot 4.6, it is possible to specify translation context. In CSV files, it can be used to disambiguate identical source strings that have different meanings. While this is generally not needed when using translation keys like this, it's usual when using plain English text as translation keys. This is done by adding a column named context column anywhere in the table, except on the first column, which is reserved for translation keys. By convention, it is recommended to place it on the second column or after plural, if it's also used. Note that it is the example below the key column in the one that contains English localization. Note, automatic control translation is not supported when using context. You must translate the string manually using tr or trn. OSV importer. Godot will treat CSV files as translations by default. It will import them and generate one or more compressed translation resource files next to it. Importing will also add the translation to the list of translations to load when the game runs. Specific in Project Godot or the project settings, Godot allows loading and removing translations at runtime as well. Select the CSV file and access the import doc to define import options. You can toggle the compression of the import translations and select the delimiter to use when parsing the CSV file. Be sure to click re-import after any change to these options. Loading the CSV file as a translation. Once a CSV file is imported, it is not automatically registered as a translation source for the project. Remember to follow these steps described in configuring the imported translation so that the translation is actually used when running the project. Localization using getTextPO files. In addition to importing translations, CSV format, Godot also supports loading translation files written like the GNU getText format, text-based PO, and compiled MO. Note, for an introduction to getText, check out a quick getText tutorial. It's written with C projects in mind, but much of the advice also applies to Godot, with the exception of xgetText. For the complete documentation, see GNU getText. Advantages. GetText is a standard format which can be edited using any text editor or GUI editors, such as PoEdit. This can be significant as it provides a lot of tools for translators, such as marking outdated strings, finding strings that haven't been translated, etc. GetText is supported by translation platforms such as Transifex and Weblate, which makes it easier for people to collaborate to localization. Compressed to CSV. GetText files work better with version control systems like Git, as each locale has its own message file. Multi-line strings are more convenient to edit in getTextPO files compared to CSV files. Disadvantages. getTextPO files have a more complex format than CSV and can be harder to grasp for people new to software localization. People who maintain localization files will have to install getText tools on their system. However, as Godot supports using text-based message files, PO translators can test their work without having to install getText tools. getTextPO files usually use English as the base language. Translators will use this base language to translate to other languages. You could use other languages as the base text, but this is not common. Installing getText tools. The command line getText tools are required to perform maintenance operations such as updating message files. Therefore, it's strongly recommended to install them. Windows. Download an installer from this page. Any architecture and binary type, shared or static works. If in doubt, choose the 64-bit static installer. For a GUI tool, you can get PoEdit from its official website. The basic version is open source and available under the MIT license. Creating the PO template. Automatic generation using the editor. Okay. The editor can generate a PO template automatically from specified scene and GD script files. This POT generation also supports translation, context, and pluralization if used in a script, with the optional second argument of tr and the trn method. Open project settings, localization template generation. Then use the add button to specify the path to your project scenes and scripts that contain localizable strings. After adding at least one scene or script, click Generate in the top right corner, then specify the path to the output file with a pot file extension. This can be placed anywhere in the project directory, but it's recommended to keep it in a subdirectory such as locale. As such, locale will be defined in its own file. See below for how to add comments for translators or exclude some strings from being added to the PO template for GDScript files. You could then move over to create a message file from a PO template. Note, remember to generate the PO template after making any changes to localizable strings, or after adding new scenes or scripts. Otherwise, newly added strings will not be localizable, and translators won't be able to update translations for outdated strings. Manual creation. If the automatic generation approach doesn't work out for your needs, you can create a PO template by hand in a text editor. This file can be placed anywhere in the project directory, but it's recommended to keep it in a subdirectory, as each locale will be defined in its own file. Create a directory named locale in the different directory. In this directory, save a file named messages.pod with the following content. Messages in getText are made of MSGID and MSGSTR pairs. MSGID is the source string, usually in English. MSGSTR will be the translated string. Warning, the MSGSTR value in PO template files.pot should always be empty. Localization will be done in the generated.po files instead. Hello, Bella. Hello. Creating a message file from a PO template. The GINIT command is used to turn a PO template into a message file. For instance, to create a French localization file, use the following command while in the local directory. The command above will create a file named fr.po in the same directory as the PO template. Alternatively, you can do that graphically using PO edit or by uploading the pot file to your web platform of choice. Loading a message file in Godot. To register a message file as a translation in a project, open in the project settings and go to Localization, Translations. Click Add, then choose the .po or .mo file in the file dialog. The locale will be inferred from the language, code, and property in the messages file. Note, see the internationalizing games for more information on importing and testing translations in Godot. Updating message files to follow the PO template. After updating the PO template, you'll have to update message files so that they contain new strings, while removing strings that are no longer present in the PO template. This can be done automatically using the MS Merge tool. If you want to keep a backup of the original message file, which would be saved as frpo tilde, in this example, remove the backup none argument. Note, after running MSG merge strings which were modified in the source language will have a fuzzy comment added before them in the .po file. This comment denotes that the translation should be updated to match the new source string, and the translation will most likely be inaccurate until it's updated. Strings with fuzzy comments will not be read by Godot until the translation is updated and the fuzzy comment is removed. Checking the validity of a PO file or template. It is possible to check whether a getText file syntax is valid. If you open the PO editor, it will display the appropriate warnings if there's some syntax errors. You can also verify by running the getText command below. If there are syntax errors or warnings, they will be displayed on the console. Otherwise, MSG FMT won't output anything. Using binary MO files, useful for large projects only. For large projects with several thousands of strings to translate or more, it can be worth it to use binary compiled MO messages files instead of text-based PO files. Binary MO files are smaller and faster to read than the equivalent PO files. You can generate an MO file with the command below. If the PO file is valid, this command will create an FRMO file besides the PO file. This MO file can then be loaded in Godot as described above. The original PO file should be kept in version control so you can update your translation in the future. In case you lose the original PO file and wish to decompile an MO file into a text-based PO file, you can do so with The decompiled file will not include comments or fuzzy strings, as these are never compiled in the MO file in the first place. Extracting localizable strings from GD script files. The built-in editor plugin recognizes a variety of patterns in source code to extract localizable strings from GD script files, including but not limited to the following: tr, trn, atr, and atrn calls, assigning up properties, text, placeholder text, and tooltip text, add tab, add item, set tab title, and other calls, file dialog filters like star.png, png images. Note, the argument or write operand must be a constant string, otherwise the plugin will not be able to evaluate the expression and will ignore it. If the plugin extracts unnecessary strings, you can ignore them with the no translate comment. You can also provide additional information for translators using the translator's comment. These comments must be placed either on the same line as a recognized pattern or precede it. Using context. The context parameter can be used to differentiate the situation where a translation is used, or to differentiate polysemic words with multiple meanings. For example, in a getTextPO file, with a context can be defined as follows. Updating PO files. Sometime or later you'll add new content to our game, and there will be new strings that need to be translated. When this happens, you'll need to update the existing PO files to include the new strings. First, generate a new POT file containing all the existing strings plus the newly added strings. After that, merge the existing PO file with the new POT file. There are two ways to do this. Use a getText editor, and it should have an option to update a PO file from a POT file. Use the getText MSG merge tool. If you want to keep a backup of the original message file, which would be saved as FRPO in this example, remove the backup none argument. POT generation custom plugin. If you have an extra file format to deal with, you could write a custom plugin to parse and extract the strings from the custom file. This custom plugin will extract the strings and write into the POT file. When you hit generate POT, to learn more about how to create translation parser plugin, see editor translation parser plugin. Local codes. Local code has the following format: language, script, country, variant, where. Language, 2 or 3 letter language code in lowercase, optional 4-letter script code in title case, optional 2-letter country code in uppercase, optional language variant, region, and sort order. A variant can have any number of underscored keywords. List of unsupported language codes. Oh, supported language codes, not unsupported. List of supported script codes. List of supported country codes. Next. Pseudo-localization. Introduction. When creating a game, the process of localization usually starts when the development has finished. This means that translations aren't available during development for testing whether the project is internalized or internationalized property. Godot offers pseudo-localization as a way to test how robust the project is when it comes to local changes. Pseudo-localization simulates changes that might take place during localization. This way, any issues regarding internationalization can be recognized early on during development. See also, you can see how pseudo-localization works in action using the pseudo-localization demo project. Enabling and configuring pseudo-localization. Enabling pseudo-localization and the configurations related to it is as simple as toggling a checkbox in the project settings. These settings can be found in project settings, general internationalization, pseudo-localization after enabling the advanced toggle in the project settings dialog. Pseudo-localization can be toggled at runtime from a script. Pseudolocalization configurations. Pseudolocalization in Godot can be set up according to the specific use case of the project. Here are the pseudolocalization properties that can be configured through project settings. Replace with accents replaces all characters in the string with their accented variants. The quick brown fox jumped over the lazy dog will be converted to the quick brown fox jumped over the lazy dog with this setting when the setting is enabled. This can be used to spot untranslated strings that won't have accents, but it is also useful to check for missing glyphs in the fonts used by the project. Double vowels. Doubles all the vowels in the string. It is a good approximation. It is a good approximation to simulate the expansion of text during localization. This can be used to check for text that would overflow its container, such as buttons. Fake biddy. Fake bidirectional text simulates right to left text. This is useful to simulate right to left writing systems to check for potential layout issues that would occur in languages using right to left scripts. Override replaces all the characters in the string with an asterisk. This is useful for quickly finding text that isn't being localized. Expansion ratio can be used in cases where doubling the vowels isn't a sufficient approximation. This setting pads the string with underscores and expands it by the given ratio. An expansion ratio of 0.3 is sufficient for most practical cases. It will increase the length of the string by 30%. Prefix and suffix. These properties can be used to specify a prefix and a suffix to wrap the text in. Skip placeholders skips placeholders for strings formatted like %s and %f. This is usually to identify places where more arguments are required for the formatted string to display correctly. All of these properties can be toggled as needed according to the project's use case. Configuring pseudolocalization at runtime. Pseudolocalization can be toggled at runtime using the pseudolocalization enabled property in translation server. However, if runtime configuration pseudolocalization properties is required, they can be directly configured using project settings setting property value, and then calling translation server reload pseudolocalization, which reparses the pseudolocalization properties and reloads the pseudolocalization. The following code snippet shall turn on replace with accents and double values properties, and then call reload pseudolocalization for the changes to get reflected. Yay! That section is done. I now want to do a thing. I want to make text with 7 by 7, right? Probably not actually, because alright, let's add another layer. Because 1, 2, 3. And there we go. These are 0, FF. 1, 2, 3, 4. Or maybe just red, green, blue. for this size, this size. 1, 2, 3, 4. House like carpet. Wait. Okay. Okay. Gonna remove this, so. And then center line. Then 2, 3, 4. Now we're just gonna increase it by 3. So 10. FF0, FF. Green, blue. Okay. So all characters for English font. Oh god. Okay, I actually don't need that. All I need is my keyboard. Probably. Alright, let's start here. Oh. Black. Yay. Hey. And now small a. Hmm. Hmm. Let's get oh, notepad. Okay, let's just close everything here. Oh. Notepad. No. A, B, C, D, E F G H I J K L M N O P Q R S T U V W X Y Z. Alright, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all of these. Alright, I think I got everything. Let's see, 1, 2, 3, 4. Okay, I should probably grab this, shift it up. Green, blue. Wait. Let us... Let's see. 0, 0, FFFF. Got a cyan. 1, 2, 3, 4, 5, 6, 7. 2, 3. FF 0, 0, FF. Oh, no, wait. 1, 2, 3. 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. What? 2, 3. 1, 2, 3, 4, 5. So then that goes here. 2, 3, 4, 5, 6, 7. And then that, okay. And then we got down here. Perfect, perfect, perfect. Okay. Let us change to black. And then, oh, I forgot. Now we can. And there we go. Now A. B. C. C. D. No. D. E. E. Yeah, that works. And now F. Now G. Hmm. That previous A worked just fine. I don't know how to do that A. So I guess I'll just come back to it. That G is quite large. Hmm. We'll just start from here. And do just the capitals for now. Because those are easier. A, B, C, D, E, F, G, H, I J sound like better. Okay. Does that look better? Yes. L M Yes. Oh, actually. Let's try that. No. That's fine. N O P Q R S T U V W, which is just M, but upside down. X Y and Z. Now 0. One. Two. Three. Four. We can either do... Hi, Bella. You want my attention, huh? Yeah? Thank you. Go get him. Alright. We can either do that for, or we can do that for. Now that for looks better. Five. Oh, what are you doing? What? Why do you want me so much? Huh? Don't go down here. Okay. Go on. Go on. Five. Six. Seven. 8. 9. 'Alright. Whatever that is. Just clearing out this list. And then tilde. Oh, wait. It's the other way. And then an exclamation mark. Oh, an at. At symbol's hard. No. It's the best I got. Hashtag. Okay. That one's simple. And this one is just super easy because I already have a base template for part of it, and then boom, the other half. That should be good. Oh. Carrot. That's the best I got for that. Asterisk. No, I can use more than that. Yeah, that works. Yeah, that's great. Okay, underscore. That one's easy. Plus. Square bracket. Curly bracket. Oh. I think we do that. Then for the other one, we do that. I think. Yep. Yeah. Yep. Yep. Oh, yeah, perfect. Does it look better? With or without? No, it looks better. Oh. Easy. Alright. So we got all of that. Now all that's left is the lowercase letters. Okay. A. Oh. Oh, there we go. Solved it. B. C. D. E. No, that just looks like a mini B. That one. Yeah, there we go. F. G H I J K. There we go. Although it doesn't quite fit within. Cause I genuinely think that's just the best I got for that. L. Wait, that just looks like the one. There we go. This one kind of has to. M. Oh, wait. Bring it down a notch. Yeah, that looks good. N O. And I should just be able to P Q R No. Think so. Mini S. Or Mini S. That one? No, probably like that. Or yes, like that? No. Hello, Shelby. You B. W. No. X. Y. Z. And there we go. Huzzah. Yay. Now let's save this. Don't save. Font. No. Pixel font. Save in browser. Yay. Alright, let's move on to the next section of the, this. 4 hours. 24 minutes, huh? God. Damn, what did we get through? We got through animation, assets pipeline, audio, export, file and data I/O, internationalization. That's actually a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 left? Got through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So we're like halfway through. Input handling. What is input event? What is it? Managing input is usually complex, so no matter the OS or platform. To use this a little, a special built-in type is provided, input event. The data type can be configured to contain several types of input events. Input events travel through the engine and can be received in multiple locations depending on the purpose. Here's a quick example. Closing your game if the escape key is hit. However, it is cleaner and more flexible to use the provided input map feature, which allows you to define input actions and assign them different keys. This way, you can define multiple keys for the same action. Example, the keyboard escape key and the start button on a gamepad. You can then more easily change this mapping in the project settings without updating your code, and even building a key mapping feature on top of it to allow your game to change the key mapping at runtime. You can set up your input map under project settings, input map, and then use those actions like this. How does it work? Every input event is originated from the user or player, though it's possible to generate an input event and feed them back to the engine, which is useful for gestures. The display server for each platform will read events from the operating system and then feed them to the root window. The Windows viewport does quite a lot of stuff with the received input in order. If the viewport is embedding Windows, the viewport tries to interpret the event in its capability as a window manager. Example for resizing or moving windows. Next, if an embedded window is focused, the event is sent to that window and processed in the Windows viewport and afterwards treated as handled. If no embedded window is focused, the event is sent to the nodes of the current viewport in the following order. First of all, the standard node input function will be called if any node that overrides it and hasn't disabled input processing. The node set process input. If any function consumes the event, it can call viewport set input is handled, and the event will not spread anymore. This ensures that you can filter all events of interest, even before the GUI for gameplay input. Node unhandled input is generally better fit because it allows for GUI to intercept the events. Second, it will try to feed the input to the GUI and see if any control can receive it. If so, the control will be called via the virtual function control control GUI input, and the signal GUI input will be emitted. This function is re-implemented by script and inherited from it. If the control wants to consume the event, it will call control.acceptEvent, and the event will not spread anymore. Use the control mouse filter property to control whether a control is notified if mouse events via control GUI input, callback, and whether these events are propagated further. If so far no one consumed the event, the node shortcut input callback will be called if overridden, and not disabled with node set process shortcut input. This happens only for input event key, input event shortcut, and input event joypad button. If any function consumes the event, it can call viewport set input as handled, and the event will not spread anymore. The shortcut input callback is ideal for treating events that are intended as shortcuts. If so far no one consumed the event, the node unhandled key input callback will be called if overridden and not disabled with node set process unhandled key input. This happens only if the event is an input event key. If any function consumes the event, it can call viewport set input as handled, and the event will not spread anymore. The unhandled key input callback is ideal for key events. If so far no one consumed the event, the node unhandled input callback will be called if overridden and not disabled with node set process unhandled input. If any function consumes the event, it can call viewport set input as handled, and the event will not spread anymore. The unhandled input callback is ideal for full screen gameplay events, so they are not received when a GUI is active. If no one wanted the event so far, the object picking is turned on. The event is used for object picking. For the root viewport, this can also be enabled in project settings. In the case of a 3D scene, if a camera is assigned to the viewport, a ray to the physics world in the ray direction from the click will be cast. If the ray hits an object, it will call the collision object 3D input event function in the relevant physics object. In the case of a 2D scene, conceptually the same happens with collision object 2D input event. While sending events to its child and descendant nodes, the viewport will do so, as depicted in the following graphic. In a reverse step, first order, starting with the node at the bottom of the scene tree and ending at the root node, excluded from this process are windows and sub-viewports. Note, this order doesn't apply to control GUI input, which uses a different method based on event, location, or focus control. GUI mouse events also travel up the scene tree, subject to the control mouse filter. Restrictions described above. However, since these events target specific controls, only direct ancestors of the targeted control nodes receive the event. GUI keyboard and joypad events do not travel up the scene tree and can only be handled by the control that received them. Otherwise, they will be propagated as non-GUI events through node unhandled input. Since viewports don't send events to the sub-viewports, one of the following methods has to be viewed. 1. Use a sub-viewport container which automatically sends events to its child sub-viewports after node input or control GUI input. Implement event propagation and based on the individual requirements. In accordance with Godot's node-based design, this enables specialized child nodes to handle and consume particular events, while their ancestors, ultimately the scene root, can provide more generalized behavior if needed. Anatomy of an input event. Input event is just a base built-in type. This does not represent anything and only contains some basic information, such as event ID, which is increased for each event, device, index, etc. There are several specialized types of input event described in the table below. Empty input event contains a key code, blah blah blah. Input actions. Input actions are a grouping of 0 or more input events into a commonly understood title. For example, the default UI left action group, both joypad left input and a keyboard's left arrow key. They are not required to represent an input event, but are useful because they abstract various inputs when programming the game logic. This allows for the same code to work on different devices with different inputs. Example, keyboard on PC, joypad on console. Input to be reconfigured at runtime. Actions to be triggered programmatically at runtime. Actions can be created from the project settings menu in the input tab input map tab, and assigned input events. Any event has the methods input event is action, input event is pressed, and input event is echo. Alternatively, it may be desired to supply the game back with an action from the game code. A good example of this is a detecting gestures. The input singleton has a method for this. Input parse input event. You would normally use it like this. See also creating input actions for a tutorial on adding input actions in the project settings. Input map. Customizing and remapping input from code is often desired. If your whole workflow depends on actions, the input map singleton is ideal for reassigning or creating different inputs at runtime. Different actions at runtime. The singleton is not saved, must be modified manually, and its state is run from the project settings, Project Godot. So any dynamic system of this type needs to store settings in the way of the program best, in the way the programmer best sees fit. Input examples. Introduction. In this tutorial, you'll learn how to use Godot's input event system to capture player input. There are many different types of input your game uses: keyboard, gamepad, mouse, etc., and many different ways to turn those inputs into actions in your game. This document will show you some of the most common scenarios, which you can use as starting points for your own projects. For a detailed overview of how Godot's input event system works, see Using Input Event. Events versus polling. Sometimes you want your game to respond to a certain input event, pressing the jump button, for example. For other situations, you might want something to happen as long as a key is pressed, such as movement in the first case. You can see the input function, which will be called whenever an input event occurs. In the second case, Godot provides the input singleton, which you can use to query the state of the input. Okay. Examples. This gives you the flexibility to mix and match the type of input processing you do. For the remainder of this tutorial, we'll focus on capturing individual events in input. Input events. Input events are objects that inherit from input event depending on the event type. The object will contain specific properties related to that event. To see what events actually look like, add a node and attach the following script. As you press keys, move the mouse, and perform other inputs, you'll see each event scroll by in the output window. Here's an example of the output. As you can see, the results are very different for the different types of input. Key events are even printed as their key symbols. For example, let's consider input event mouse button. It inherits the following class: input event, the base class for all input events. Input event with modifiers adds the ability to check if the modifiers are pressed, such as Shift or Alt. Input event mouse adds mouse event properties such as position. Input event mouse button contains the index of the button that was pressed, whether it was a double click, etc. Tip: it's a good idea to keep the class reference open while you're working with events, so you can check the event's type, available properties, and methods. You can encounter errors if you try to access a property on an input type that doesn't contain calling position or input key event, for example. To avoid this, make sure to test the event type first. Input map. The input map is the most flexible way to handle a variety of inputs. You use this by creating named input actions, to which you can assign any number of input events, such as key presses or mouse clicks. To see them and add your own open project, project settings, and select the Input Map tab. Tip: a new Godot project includes a number of default actions already defined. To see them, turn on Show Built-in Actions in the Input Map dialog. Capturing actions. Once you've defined your actions, you can process them in your scripts using is action pressed and is action released by passing the name of the action you're looking for. Keyboard events. Keyboard events are captured in input key event. While it's recommended to use input actions instead, there may be cases where you want to specifically look at key events. For this example, let's check for the T. Tip C at global scope key for a list of key code constants. Warning, due to keyboard ghosting, not all key inputs may be registered at a given time if you press too many keys at once, due to their location on the keyboard. Certain keys are more prone to ghosting than others. Some keyboards featuring anti-ghosting at a hardware level, but this feature is generally not present on low-end keyboards and laptop keyboards. As a result, it's recommended to use a default keyboard layout that is designed to work well on a keyboard without anti-ghosting. See this Game Dev Stack Exchange question for more information. I drank it weird. Keyboard modifiers. Modifier properties are inherited from input event with modifiers. This allows you to check for modifier combinations using Boolean properties. Let's imagine you want one thing to happen with the T when the T is pressed, but something different when it's Shift T. See at global scope key for a list of key code combinations. Mouse events. Mouse events stem from the input event mouse class and are separated into two types: input event mouse button and input event mouse motion. Note that this means that all mouse events will contain a position property. Mouse buttons. Capturing mouse buttons is very similar to handling key events. And global scope mouse button contains a list of mouse button star constants for each possible button, which will be reported in the events button index property. Note that the scroll wheel also counts as a button. 2 buttons to be precise, with both mouse button wheel up and mouse button wheel down being separate events. Mouse motion, input event mouse motion. Events occur whenever the mouse moves. You can find the move's distance with the relative property. Here's an example using mouse events to drag and drop a Sprite 2D node. Touch events. If you are using a touchscreen device, you can generate touch events. Input event screen touch is equivalent to a mouse click event. An input event screen drag works much the same as mouse motion. Tip: to test your touch events on a non-touchscreen device, open project settings and go to input devices pointing section. Enable emulate touch from mouse and your project will interpret mouse clicks and motion as touch events. Mouse and input coordinates. The reason for this small tutorial is to clear up many common mistakes about input coordinates, obtaining mouse position and screen resolution, etc. Hardware display coordinates. Using hardware coordinates makes sense if, in the case of writing complex UIs meant to run on PC, such as editors, MMOs, tools, etc. However, it does not make as much sense outside of that scope. Viewport display coordinates. Godot uses viewports to display content, and viewports can be scaled by several options. See multiple resolutions tutorial. Use then the functions and nodes to obtain the mouse coordinates and viewport size, for example. Alternatively, it's possible to ask the viewport for the mouse position. Note, when the mouse mode is set to input mouse mode captured, the event position value from input event mouse motion is the center of the screen. Use event relative instead of event position and event velocity to process mouse movement and position changes. When implementing features such as mouse look, it's recommended to use event screen relative and event screen velocity instead of event relative and event velocity, so that mouse movement behaves the same across multiple resolutions. Customizing the mouse cursor. You might want to change the appearance of the mouse cursor in your game in order to suit the overall design. There are 2 ways to customize the mouse cursor. 1, using project settings. This is simpler but more limited. Using a script. 2, using a script. This is more customizable but involves scripting. Note, you could display a softer mouse cursor by hiding the mouse cursor and moving a Sprite 2D to the cursor position in a process method. But this will add at least 1 frame of latency compared to a hardware mouse cursor. Therefore, it's recommended to use the approach described here whenever possible. If you have to use the software approach, consider adding an extrapolation step to better display the actual mouse input. Using project settings. Open the project settings and go to display mouse cursor. You will see the settings custom image hotspot, and tooltip position offset. Custom image is the desired image that you would like to set as the mouse cursor. Custom hotspot is the point in the image that you would like to use as the cursor's detection point. Warning, the custom image must be 256 by 256 pixels at most. To avoid rendering issues, sizes of 128 by 128 or smaller are recommended. On the web platform, the maximum allowed cursor image size is 128 by 128. Using a script. Create a node and attach the following script. See, also check input set custom mouse cursor. The documentation for more information on usage and platform-specific caveats. Cursor list. There are multiple mouse cursors you can define. Documented in the input cursor shape enum. Which ones you want to use depends on your use case. Controllers, gamepads, and joysticks. Godot supports hundreds of controller models out of the box. Controllers are supported on Windows, macOS, Linux, Android, iOS, and web. Note, since Godot 4.5, the engine relies on SDL3 for controller support on Windows, macOS, and Linux. This means a list of supported controllers and their behavior should closely match what is available in other games and engines using SDL3. Note that SDL is only used for input, not for windowing or sound. Prior to Godot 4.5, the engine used its own controller support code. This can cause certain controllers to behave incorrectly. This custom code is still used to perform controllers on Android, iOS, and web, so it may result in issues appearing only on web platforms. Note that more specialized devices such as steering wheels, rudder pedals, and HOTAs HOTAs are less tested and may not always work as expected. Overriding force feedback for those devices is also not implemented yet. If you have access to one of those devices, don't hesitate to report bugs on GitHub. In this guide, you will learn how to write your input logic to support both keyboard and controller inputs, how controllers can behave differently from keyboard or mouse input, troubleshooting issues with controllers in Godot, supporting universal input. Thanks to Godot's input action system, Godot makes it possible to support both keyboard and controller input without having to write separate code paths. Instead of hard-coding keys or controller buttons in your script, you should create input actions in the project settings, which will then refer to specific key and controller inputs. Input actions are explained in detail on the Using Input event page. Note, unlike keyboard input, supporting both mouse and controller input for an action, such as looking around in a first-person game, will require different code paths since these have to be handled separately. Which input singleton method should I use? There are three ways to get input in an analog-aware way. When you have two axes, such as joystick or WASD movement, and want both axes to behave as a single input, use input.getVector. When you have one axis that can go both ways, such as throttle on a flight stick, or you want to handle separate axes individually, use input.getAxis. For other types of analog input, such as handling a trigger or handling one direction at a time, use input.getActionStrength. For non-analog, digital, or Boolean input, only pressed or non-pressed values, such as controller buttons, mouse buttons, or keyboard keys, use input.isActionPressed. Note, if you need to know whether an input was just pressed in the previous frame, use input.isActionGetJustPressed instead of input.isActionPressed. Unlike input.isActionPressed, which returns true as long as the input is held, input.isActionJustPressed will only return true for one frame after the button has been pressed. Vibration. Vibration, also called haptic feedback, can be used to enhance the feel of a game. For instance, in a racing game, you can convey the surface of the car is currently driving on through vibration, or create a sudden vibration on a crash. Use the input singleton start joy vibration method to start vibrating a gamepad. Use stop joy vibration to stop vibration early. Useful if no duration was specified when starting. On mobile devices, you can also use vibrate handheld to vibrate the device itself, independently from the gamepad. On Android, this requires the vibrate permission to be enabled in the Android export preset before exporting to the project. Note, vibration can be uncomfortable for certain players. Make sure to provide an in-game slider to disable vibration or reduce its intensity. Differences between keyboard, mouse, and controller input. If you're used to handling keyboard and mouse input, you may be surprised by how controllers handle specific situations. Dead zone. Unlike keyboards and mice, controllers offer axes and analog inputs. The upside of analog inputs is that they offer additional flexibility for actions, unlike digital inputs which can only provide strengths of 0 and 1. An analog input can provide any strength between 0 and 1. The downside is that without a dead zone system, an analog's axis strength will never be equal to 0 due to how the controller is physically built. Instead, it will linger at a low value such as 0.062. This phenomenon is known as drifting and can be more noticeable on old or faulty controllers. Let's take a racing game as a real-world example. Thanks to analog inputs, we can steer the car slowly in one direction or another. However, without a dead zone system, the car would slowly steer itself even if the player isn't touching the joystick. This is because the directional axis strength won't be equal to 0 when we expect it to. Since we don't want our car to steer by itself in this case, we define a dead zone value of 0.2, which will ignore all inputs whose strength is lower than 0.2. An ideal dead zone value is high enough to ignore the input caused by joystick drifting, but is low enough to not ignore actual input from the player. Godot features a built-in dead zone system to tackle this problem. The default value is 0.5, but you can adjust it on a per action basis in the project settings input map tab for input get vector. The dead zone can be specified as an optional fifth parameter. If not specified, it will calculate the average dead zone value from all of the actions in the vector. Echo events. Unlike keyboard input, holding down a controller button such as a D-pad direction will not generate repeated events at fixed intervals, also known as echo events. This is because the operating system never sends echo events for controller input in the first place. If you want controller buttons to send echo events, you will have to generate input event objects by code and parse them into input parse input event at regular intervals. This can be accomplished with the help of a timer node. Window focus. Unlike keyboard input, controller inputs can be seen by all windows on the operating system, including unfocused windows. While this is useful for third-party split-screen functionality, it can also have adverse effects. Players may accidentally send controller inputs to the running project while interacting with another window. If you wish to ignore events when the project's window isn't focused, you'll need to create an autoload called focus with the following script and use it to check all your inputs. Then, instead of using input is action pressed action, use focus input is action pressed action, where action is the name of the input action. Also, instead of using event is action pressed action, use focus event is action pressed event action, where event is an input event reference and action is the name of the input action. God, this is a lot of reading. Good God. Power saving prevention. Unlike keyboard and mouse input, controller inputs do not inhibit sleep and power-saving measures, such as turning off the screen after a certain amount of time has passed. To combat this, Godot enables power-saving prevention by default when a project is running. If you notice the system is turning off its display when playing with a gamepad, check the value of display window energy saving. Keep screen on in the project settings. Troubleshooting. See also, you can view a list of known issues with controller support on GitHub. My controller isn't recognized by Godot. First, check that your controller is recognized by other applications. You can use the Gamepad Tester website to confirm that your controller is recognized. On Windows, Godot only supports up to 4 controllers at a time. This is because Godot uses an X-input API, which is limited to supporting 4 controllers at once. Additional controllers above this limit are ignored by Godot. My controller has incorrectly mapped buttons or axes. First, if your controller provides some kind of firmware update utility, make sure to run it to get the latest fixes from the manufacturer. For instance, Xbox One and Xbox Series controllers can have their firmware updated using the Xbox Accessories app. This application only runs on Windows, so you have to use a Windows matching or a Windows virtual machine with USB support to update the controller's firmware. After updating the controller's firmware, unpair the controller and pair it again with your PC if you are using the controller in wireless mode. If buttons are incorrectly mapped, this may be due to an erroneous mapping from the SDL game controller database used by Godot for the Godot game controller database. In this case, you will need to create a custom mapping for your controller. There are many ways to create mappings. One option is to use the mapping wizard in the official Joypads demo. Once you have working mapping for your controller, you can test it by defining the SDL game controller config environment variable before running Godot. To test mappings on non-desktop platforms or to distribute your project with additional controller mappings, you can add them by calling input add joy mapping as early as possible in the script's ready function. Once you are satisfied with the custom mapping, you can contribute it for the next Godot version by opening a pull request on the Godot game controller database. A controller works on a given platform, but not on another platform. Okay. Somebody messaged me. Alright. None. Oh, what now? Okay. Controller features. Godot supports supports controller-specific features that can further enhance the gameplay experience. This page describes these features, how existing games have used them, and how you can get started with them in Godot. Warning, these controller features are currently only supported on Windows, macOS, and Linux. Warning, unless you specifically advertise your game as requiring specific controllers, remember that there is no guarantee that players will have a controller with a given feature. As a result, we suggest using these features to enhance the gameplay experience for players whose controllers support them, without detracting from those who don't have controllers. LED color. Games can use the LED lights on certain controllers to subtly complement the on-screen gameplay by providing some matching visuals in the player's hands. Here are some notable examples. In Hades, the color of the light matches the god you're receiving a boon from. In Resident Evil 2, the color of the light indicates your health: green for full, yellow for medium, red for low. In Star Wars Jedi Fallen Order, the color of the light matches your lightsaber's color. Use the method input set joy light to set the color of a given controller's LEDs. To determine if a given controller supports setting LED lights, use the input has joy light method. The PlayStation, DualShock, and DualSense controllers are known to support LED lights. The following process method sets the LED color according to the currently pressed button, and turns it off if no button is being pressed. The following example smoothly fades the LED through hues in a loop. The following example makes the LED blink red 3 times when the south button, cross X on PlayStation controllers, is pressed. Handling quit requests. Quitting. Most platforms have the option to request the application to quit. On desktop, this is usually done with the X icon in the window title bar. On mobile devices, the app can quit at any time while it is suspended to the background. Handling the notification. On desktop and web platforms, Node receives a special notification, WM close request notification, when quitting is requested from the window manager. Handling the notification is done as follows on any node. It is important to note that by default, Godot apps have the built-in behavior to quit when quit is requested from the window manager. This can be changed so that the user can take care of the complete quitting procedure. On mobile devices, sending your own quit notification. While forcing the application to close can be done by calling scene tree quit, doing so will not send the notification WM close request to the nodes in the scene tree. Quitting by calling scene tree quit will not allow custom actions to complete, such as saving, confirming the quit, or debugging, even if you try to delay the line that forces the quit. Instead, you want to notify the nodes in the scene tree about the upcoming program termination. You should send the notification yourself. Sending this notification will inform all nodes about the program termination, but will not determine the program itself, unlike in 3x, in order to achieve the previous behavior. Scene tree quit should be called after the notification. Yay, math. Math is fun. Do we have time for that though? 1, 2, 3, 4, 5, 6. They're fairly long. Yeah, we've got time. We can do this and then we'll probably be good to be done. Probably. Vector Math Introduction. This tutorial is a short and practical introduction to linear algebra, as it applies to game development. Linear algebra is the study of vectors and their uses. Vectors have many applications of both 2D and 3D development, and Godot uses them extensively. Developing a good understanding of vector math is essential to becoming a strong game developer. Note, the tutorial is not a formal textbook on linear algebra. We will only be looking at how it is applied to game development. For a broader look at mathematics, see that. Khan Academy, huh? Coordinate systems 2D. In 2D space, coordinates are defined using a horizontal axis x and a vertical axis y. A particular position in space in 2D space is written as a pair of values such as 4, 3. Note, if you're new to computer graphics, it might seem odd that the y-axis points downwards instead of upwards, as you probably learned in math class. However, this is common in most computer graphics applications. Any position in the 2D plane can be identified by a pair of numbers in this way. However, we can also think of the position 4, 3 as an offset from the 0, 0 point or origin. Draw an arrow pointing from the origin to the point. This is a vector. A vector represents a lot of useful information, as well as telling us the point is at 4, 3. We can also think of it as an angle, theta, and a length or magnitude, m. In this case, the arrow is a position vector. It denotes a position in space relative to the origin. A very important point to consider about vectors is that they only represent relative direction and magnitude. There is no concept of a vector's position. The following two vectors are identical. Both vectors represent a point 4 units to the right and 3 units below some starting point. It does not matter where on the plane you draw the vector. It always represents a relative direction and magnitude. Vector operations. You can use either method x, either method x and y coordinates or angle and magnitude to refer to a vector, but for convenience, programmers typically use the coordinate notation. For example, in Godot, the origin is the top left corner of the screen, so to place a 2D node named node 2D, 400 pixels to the right and 300 pixels down, use the following code. Godot supports both vector 2 and vector 3 for 2D and 3D usage, respectively. The same mathematical rules discussed in this article apply to both types and wherever we link to vector 2 methods in the class reference. You can also check out the vector 3 counterparts. Member access. The individual components of the vector can be accessed directly by name. Adding vectors. When adding or subtracting two vectors, the corresponding components are added. Variable c equals a plus b. We can also see this visually by adding the second vector at the end of the first line. Note that adding a plus b gives the same result as b plus a. Scalar multiplication. Note, vectors represent both direction and magnitude. A value representing only magnitude is called a scalar. Scalars use the float type in Godot. A vector can be multiplied by a scalar. Note, multiplying a vector by a positive scalar does not change its direction, only its magnitude. Multiplying with a negative scalar results in a vector in the opposite direction. This is how you scale a vector. Practical applications. Let's look at two common uses for vector addition and subtraction. A vector can represent any quantity with a magnitude and direction. Typical examples are position, velocity, acceleration, and force. In this image, the spaceship at step 1 has a position vector of 1, 3 and a velocity vector of 2, 1. The velocity vector represents how far the ship moves each step. We can find the position for step 2 by adding the velocity to the current position. Tip: velocity measures the change in position per unit of time. The new position is found by adding the velocity multiplied by the elapsed time. Here assumes to be 1 unit, e.g. 1 second, to the previous position. In a typical 2D scenario, you would have a velocity in pixels per second and multiply it by the delta parameter, time elapsed since the previous frame, from the process or physics process callbacks, pointing toward a target. In this scenario, you have a tank that wishes to point its target at a robot. Subtracting the tank's position from the robot's position gives the vector pointing from the tank to the robot. Tip: to find a vector pointing from A to B, use B minus A. Unit vectors. A vector with magnitude of 1 is called a unit vector. They are also sometimes referred to as direction vectors or normals. Unit vectors are helpful when you need to keep track of a direction. Normalization. Normalizing a vector means reducing its length to 1 while preserving its direction. This is done by dividing each of its components by its magnitude. Because this is such a common operation, Godot provides a dedicated normalized method for this. Warning: because normalization involves dividing by the vector's length, you cannot normalize a vector of length 0. Attempting to do so would normally result in an error. In GDScript, though, trying to call the normalized method of vector length 0 leaves the value untouched and avoids the error for you. Reflection. A common use of unit vectors is to indicate normals. Normal vectors are unit vectors aligned perpendicularly to a surface, defining its direction. They are commonly used for lighting, collisions, and other operations involving surfaces. Ugh. For example, imagine we have a moving ball that we want to bounce off a wall or other object. The surface normal has a value of 0 minus 1. Because this is a horizontal surface, when the ball collides, we take its remaining motion. The ball left over when it hits the surface and reflect it using the normal in Godot. There is a bounce method to handle this. Here is a code example of the above diagram using a character body 2D. Dot product. The dot product is one of the most important concepts in vector math, but is often misunderstood. Dot product is an operation on two vectors that return a scalar. Unlike a vector which contains both magnitude and direction, a scalar value has only magnitude. The formula for a dot product takes two common forms: that and that. The mathematical notation A represents the magnitude of a vector, A, and AX means the component of vector A. However, in most cases, it is easiest to use the built-in dot method. Note that the order of the two vectors does not matter. The dot product is most useful when used with unit vectors, making the first formula reduced to just cosine of 0, or cosine theta. This means we can use the dot product to tell us something about the angle between two vectors. When using unit vectors, the result will always be between -1, 180, and 1, 0. Facing. We can use this fact to detect whether an object is facing toward another object. In the diagram below, the player P is trying to avoid zombies A and B. Assuming a zombie's field of view is 180, can they see the player? The green arrows FA and FB are unit vectors representing the zombie's facing direction, and the blue semicircle representing its field of view. For zombie A, we find the direction vector AP pointing to the player using PA and normalize it. However, Godot has a helper method to do this called direction 2. If the angle between this vector and the facing vector is less than 90 degrees, then the zombie can see the player. In code, it would look like this. Cross product. Like the dot product, the cross product is an operation on two vectors. However, the result of the cross product is a vector with a direction that is perpendicular to both. Its magnitude depends on their relative angle. If two vectors are parallel, the result of their cross product will be a null vector. The cross product is calculated like this. With Godot, you can use the built-in vector3 cross method. The cross product is not mathematically defined in 2D. The vector2 cross method is a commonly used analog of the 3D cross product for 2D vectors. In the cross product, order matters. A cross B does not give the same result as B cross A. The resulting vectors point in the opposite directions. Calculating normals. One common use of cross products is to find the surface normal of a plane or surface in 3D space. If we have the triangle ABC, we can use vector subtraction to find two edges AB and AC. Use the cross product AB times AC produces a vector perpendicular to both the surface normal. Here's a function to calculate a triangle's normal, pointing to a target. In the point product section above, we saw how it could be used to find the angle between two vectors. However, in 3D, this is not enough for information. We also need to know what axis to rotate around. We can find that by calculating the cross product of the current facing direction and the target direction. The resulting perpendicular vector is the axis rotation. More information. For more information on using vector math in Godot, see the following articles: Advanced Vector Math in Matrices and Transforms. But we're going to Advanced Vector Math next, so... Advanced Vector Math. Planes. The dot product has another interesting property with unit vectors. Imagine that perpendicular to that vector and through the origin passes a plane. Planes divide the entire space into positive over the plane and negative under the plane. And contrary to popular belief, you can also use their math in 2D. Unit vectors that are perpendicular to a surface, so they describe the orientation of the surface, are called unit normal vectors, though usually they are just abbreviated as normals. Normals appear in planes, 3D geometry, to determine where each face or vertex is sighting, etc. A normal is a unit vector, but it's called normal because of its usage, just like we call 0, 0 the origin. The plane passes by the origin and the surface of its perpendicular to the unit vector, or normal. The side the vector points to is the positive half space, while the other side is the negative half space. In 3D, this is exactly the same, except that the plane is an infinite surface. Imagine an infinite flat sheet of paper that you can orient and is pinned to the origin instead of a line. Distance to plane. Now that it's clear that what a plane is, let's go back to the dot product. The dot product is between a unit vector and any point in space. Yes, this time we do dot product between vector and position, returns the distance from the point to the plane. But not just the absolute distance. If the point is in the negative half space, then distance will be negative 2. This allows us to tell which side of the plane a point is, away from the origin. I know what you are thinking. So far, this is nice, but real planes are everywhere in space, not only passing through the origin. You want real plane action, and you want it now. Remember that planes not only split space in two, but they also have polarity. This means that it is possible to have perfectly overlapping planes, but their negative and positive half spaces are swapped. With this in mind, let's describe a full plane as a normal, n, and a distance from the origin scalar d. Thus, our plane is represented by n and d, for example. For 3D math, Godot provides a plane built-in type that handles this. Basically, n and d can represent any plane in space, be it for 2D or 3D, depending on the amount of dimensions of n. And the math is the same for both. It's the same as before, but 2D is the distance from the origin to the plane, traveling in n direction as an example. Imagine you want to reach a point in the plane. You will just do that. This will resize the normal vector and make it touch the plane. The math might seem confusing, but it's actually much simpler than it seems. If you want to tell again the distance from the point to the plane, we do the same, but adjusting for distance. The same thing using a built-in function. This will again return either a positive or negative distance. Flipping the polarity of the plane can be done by negative both n and d. This will result in a plane in the same position, but with inverted negative and positive half spaces. Godot also implements this operator in plane, so using the format below will work as expected. So remember, the plane's main practical use is what we can calculate the distance to. Cable unplugged. So when it is useful to calculate distance from a point to a plane. Let's see some examples. Constructing a plane in 2D. Planes clearly don't come out of nowhere, so they must be built. Constructing them in 2D is easy. This can be done from either a normal unit vector and a point, or from 2 points in space. In the case of a normal and a point, most of the work is done, as the normal is already computed. So calculate d from the dot product and the normal and the point. For 2 points in space, there are actually 2 planes that pass through them, sharing the same space but with normal pointing to the opposite directions. To compute the normal from the 2 points, the direction vector must be obtained first, and then it needs to be rotated 90 degrees to either side. The rest is the same as the previous example. Either point A or point B will work, as they are in the same plane. Doing the same in 3D is a little more complex and explained further down. Some examples of planes. Here's an example of what planes are useful for. Imagine you have a convex polygon, for example, and a rectangle, a trapezoid, a triangle, or just any polygon, where no faces bend inwards. For every segment of the polygon, we compute the plane that passes by the segment. Once we have the list of planes, we can do neat things. For example, checking if a point is inside the polygon. We go through all planes. If we can find a plane where the distance to the point is positive, then the point is outside the polygon. If we can't, then its point is inside. Code should be something like this. Pretty cool, huh? But this gets much better. With a little more effort, similar logic will let us know what two convex polygons are overlapping to. This is called the separating axis theorem, or SAT, and most physics engines use this to detect collision. With a point, just checking if a plane returns a positive distance is enough to tell if the point is outside with another polygon. We must find a plane where all the other polygon points return a positive distance to it. This check is performed with the planes of A against the points of B, and then with the planes of B against the points of A. Code should be something like this. As you can see, planes are quite useful, and this is the tip of the iceberg. You might be wondering what happens with non-convex polygons. This is usually just handled by splitting the concave polygon into smaller convex polygons, or using a technique such as BSP, which is not used much nowadays. Collision detection in 3D. This is another bonus bit. A reward for being patient and keeping up with this long tutorial. Here is another piece of wisdom. This might not be something with a direct use case. Godot already does collision detection pretty well, but it's used by almost all physics engines and collision detection libraries. Remember that converting a convex shape in 2D to an array of 2D planes was useful for collision detection. You could detect if a point was inside any convex shape, or if two 2D convex shapes were overlapping. Well, this works in 3D too. If two 3D polyhedral shapes are colliding, you won't be able to find a separating plane. If a separating plane is found, then the shapes are definitely not colliding. To refresh a bit, a separating plane means that all vertices of the polygon A are in one side of the plane, and all vertices of polygon B are in the other side. This plane is always on the face planes of either polygon A or polygon B. In 3D, though, there is a problem to this approach, because it is possible that in some cases a separating plane can't be found. This is an example of such situation. To avoid it, some extra planes need to be tested as separators. These planes are the cross product between the edges of a polygon A and the edges of polygon B. So the final algorithm is something like... That's a lot. More information. For more information on using vector math in Godot, see the following article, Matrices and Transforms. If you would like additional explanation, you should check out 3 Blue 1 Brown's excellent video series, Essence of Linear Algebra. Matrices and Transforms. Introduction. Before reading this tutorial, we recommend that you thoroughly read and understand Vector Math tutorial, as this tutorial requires a knowledge of vectors. This tutorial is about transformations and how we represent them in Godot using matrices. It is not a full in-depth guide to matrices. Transformations are most of the time applied as translation, rotation, and scale, so we will focus on how to represent those with matrices. Most of this guide focuses on 2D using Transform 2D and Vector 2D, but the way things work in 3D is very similar. Note, as mentioned in the previous tutorial, it is important to remember that in Godot, the y-axis points down in 2D. This is the opposite of how most schools teach linear algebra, and the y-axis points up, pointing up. Note, the convention is that the x-axis is red and the y-axis is green and the z-axis is blue. This tutorial is color-coded to match these conventions, but we also represent the origin vector with a blue color. Matrix components and the identity matrix. The identity matrix represents a transform with no translation, no rotation, and no scale. Let's start by looking at the identity matrix and how its components relate to how it visually appears. Matrices have rows and columns, and a transformation matrix has specific conventions on what each does. In the image above, we can see that the red x vector is represented by the first column of the matrix, and the green y vector is likewise represented by the red column. A change to the columns will change these vectors. We will see how they can be manipulated in the next few examples. You should not worry about manipulating rows directly, as we usually work with columns. However, you can think of the rows of the matrix as shown with vectors, which vectors contribute to moving in a given direction. When we refer to a value such as txy, that's the y component of the column vector. In other words, the bottom left of the matrix, similarly, txx, is top left, tyx is top right, and tyy is bottom right, where t is the transform 2D. Scaling the transformation matrix. Applying a scale is one of the easiest operations to understand. Let's start by placing the Godot logo underneath our vectors so that we can visually see the effects of an object. Now, to scale the matrix, all we need to do is multiply each component by the scale we want. Let's scale it up to 2.1 times 2 becomes 2, and 0 times 2 becomes 0, so we end up with this. To do this in code, we multiply each of the vectors. If we want to return it to its original scale, we can multiply each component by 0.5. That's pretty much all there is to scaling a transformation matrix. To calculate the object's scale from an existing transformation matrix, you can use the length on each of the column vectors. Note, in actual projects, you can use the scaled method to perform scaling. Rotating the transformation matrix. We'll start the same way as earlier, with the Godot logo underneath the identity matrix. As an example, let's say we want to rotate our Godot logo clockwise by 90 degrees. Right now, the x-axis points right and the y-axis points down. If we rotate these in our head, we would logically see that the new x-axis should point down and the new y-axis should point left. You can imagine that you grab both of the Godot logo and its vectors, and then spin it around the center. Wherever you finish spinning, the orientation of the vectors determines what the matrix is. We need to represent down and left in normal coordinates, so means we'll set x to 0, 1, and y to -1, 0. These are also the values of vector 2 down and vector 2 left. When we do this, we get the desired result of rotating the object. If you have trouble understanding the above, try this exercise. Cut a square of paper, draw x and y vectors on top of it, place it on graph paper, then rotate it and note the endpoints. To perform rotation in code, we need to be able to calculate the values programmatically. This image shows the formulas needed to calculate the transformation matrix from the rotation angle. Don't worry if this part seems complicated. I promise it's the hardest thing you need to know. Cosine rotation, sine rotation, negative sine rotation, cosine rotation. Note, Godot represents all rotations with radians, not degrees. A full turn is tau or pi times 2 radians, and a quarter turn of 90 degrees is tau divided by 4 or pi divided by 2 radians. Working with tau usually results in more readable code. Note, fun fact, in addition to y being down in Godot, rotation is represented clockwise. This means that all the math and trig functions behave the same as a y is up CCW system. Since these differences cancel out, you can think of rotations in both systems being from x to y. In order to perform a rotation of 0.5 radians, about 28.65 degrees, we plug in a value of 0.5 to the formula above and evaluate to find what the actual values should be. Here's how that would be done in code. Place a script on a node 2D. To calculate the object's rotation from an existing transformation matrix, you can use a tangent to txy, txx, where t is a transformed 2D. Note, in actual projects, you can use the rotated method to perform rotations. Basis of the transformation matrix. So far, we have only been working with the x and y vectors, which are in charge of representing rotation, scale, and or shearing. Advanced covered at the end. The x and y vectors are together called the basis of the transformation matrix. The terms basis and basis vectors are important to know. You might have noticed that Transform 2D actually has 3 vectors, values x, y, and origin. The origin value is not part of the basis, but is part of the transform, and we need it to represent position. From now on, we'll keep track of the origin vector in all examples. You can think of origin as another column, but it's often better to think of it as completely separate. Note that in 3D, Godot has a separate basis structure for holding the three values of the basis. Since the code can be complex and it makes sense to separate it from Transform 3D, which is composed of one basis and one extra vector for the origin. Translating the transformation matrix. Changing the origin vector is called translating the transformation matrix. Translating is basically a technical term for moving the object, but it explicitly does not involve any rotation. Let's work through an example to help understand this. We will start with the identity transform like last time, except we will keep track of the origin vector this time. If we want to move the object to a position of 1, 2, we need to set its origin vector to 1, 2. There is also a translated local method which performs a different operation to adding or changing origin directly. The translated local method will translate the object relative to its own rotation. For example, an object rotated 90 degrees clockwise will move to the right when translated local with a vector 2 up to translate relative to the global parent frame to use translated instead. Note, Godot's 2D uses coordinates based on pixels, so in actual projects you will want to translate by hundreds of units. Putting it all together, we're going to apply everything we mentioned so far onto one transform. To follow along, create a project with the Sprite 2D node and use the Godot logo for the texture resource. Let's set the translation to 350, 150, rotate by -0.5 radians, and scale by 3. I've posted a screenshot in the code to reproduce it, but I encourage you to try and reproduce the screenshot without looking at the code. Sharing the transform matrix advanced. Note, if you are only looking for how to use transform matrices, feel free to skip this section of the tutorial. This section explores an uncommonly used aspect of transformation matrices for the purpose of building an understanding of them. Node 2D provides a sharing property out of the box. You may have noticed that a transform has more degrees of freedom than a combination of the above actions. The basis of a 2D transformation matrix has 4 total numbers in 2 vector 2 values, while a rotation value and a vector 2 for scale only has 3 numbers. The high-level concept for the missing degree of freedom is called shearing. Normally, you would always have the basis vectors perpendicular to each other. However, shearing can be useful in some situations, and understanding shearing helps you understand how transforms work. To show you visually how it will look, let's overlay a grid onto the Godot logo. Each point on the grid is obtained by adding the basis vectors together. The bottom right corner is x plus y, while the top right corner is x minus y. If we change the basis vectors, the entire grid moves with it, as the grid is composed of the basis vectors. All lines on the grid are currently parallel, will remain parallel no matter what changes we make to the basis vectors. As an example, let's set y to 1, 1. Interesting. Note, you can't set the raw values of the Transform 2D in the editor, so you must use code. If you want to shear the object. Due to the vectors no longer being perpendicular, the object has been sheared. The bottom center of the grid, which is 0, 1, relative to itself, is now located at a world position of 1, 1. In the intra-object coordinates are called UV coordinates in textures, so let's borrow that terminology for here. To find the world position from a relative position, the formula is u times x plus v times y, where u and v are numbers and x and y are the basis vectors. On the bottom right corner of the grid, which is always at the UV position of 1, 1, is at the world position of 2, 1, which is calculated from x times 1 plus y times 1, which is 1, 0, and 1 plus 1, or 1 plus 1, or 0 plus 1, or 2, 1. This matches up with our observations of where the bottom right corner of the image is. Similarly, the top right corner of the grid, which is always at the UV position of 1 minus 1, is at the world position of 0 minus 1, which is calculated from x times 1 plus y times negative 1, which is 1, 0, minus 1, 1, or 1 minus 0, 0 minus 1, or 0 minus 1. This matches up with our observation of where the top right corner of the image is. Hopefully you now fully understand how a transformation matrix affects the object, and the relationship between the basis vectors and how the object's UV or intra-coordinates have their world position changed. Note, in Godot, all transform math is done relative to the parent node. When we refer to world position, that would be relative to the node's parent instead, if the scale had a parent. If you would like additional explanation, you should check out 3 Blue 1 Brown's excellent video about linear transformations. Practical applications of transforms. In actual projects, you will usually be working with transforms inside transforms by having multiple Node 2D or Node 3D nodes parented to each other. However, it's useful to understand how to manually calculate the values we need. We will go over how you could use Transform 2D or Transform 3D to manually calculate transforms of nodes. Converting positions between transforms. There are many cases where you'd want to convert a position in and out of a transform. For example, if you have a position relative to a player and would like to find the world parent relative position, or if you have a world position you want to know where it is relative to the player. We can find what a vector relative to the player would be defined in world space as using the star operator. And we can use the operator in the opposite order to find what world space position would be if it was defined relative to the player. If you know in advance that the transform is positioned at 0, 0, you can use the basis x form for basis x form inv methods instead, which skip dealing with translation. Moving an object relative to itself. A common operation, especially in 3D games, is to move an object relative to itself. For example, in first-person shooter games, you would want the character to move forward, negative z-axis, when you press W, since the basis vectors are the orientation relative to the parent, and the origin vector is the positive relative to the parent. We can add multiples of the basis vectors to add an object relative to itself. This code moves an object 100 units to its own right. For moving in 3D, you would need to place x with basis x. In actual projects, you can use translate object locale in 3D, or move local x and move local y in 2D to do this. Applying transforms onto transforms. One of the most important things to know about transforms is how you can use several of them together. A parent's node transform affects all of its children. Let's dissect an example. In this image, the child node has a 2 after the component names to distinguish them from the parent node. It might look a bit overwhelming with so many numbers, but remember that each number is displayed twice. Next, the arrows, and also in the matrices, and that almost half of the numbers are 0. The only transformations going on here are that the parent node has been given a scale of 2, 1, the child has been given a scale of 0.5, 0.5, and both nodes have been given positions. All child transformations are affected by the parent transformations. Hi, how are you?
Good.
What you up to?
What?
What are you up to?
Okay, I lied. I was testing Risk of Rain mods.
Okay. Well, that's
Jesse
fun.
and I are both... Yeah. Jesse and I are both, down to do the run tonight if you are.
Yeah, I can after I finish the math section and the documentation. But yeah, you two test out the mod pack or whatever. And then
It's already solid and stuff. I've
yeah.
not gonna do anything else to it tonight. I've put the code in the group chat already.
Okay. Well, expect maybe like 30 minutes, maybe?
Okay.
I'm like, I want to say halfway through the math section. Also, this section is really fun, for me, at least.
Nerd.
It's going over vectors and matrices, currently.
Oh yeah. Vector.
Good God. All child transformations are affected by the parent transformations. The child has a scale of 0.5, so you would expect it to be a 1-1 ratio square, and it is but only relevant to its parent. The child's x vector ends up being 1-0 in world space, but it is scaled by the parent's basis vectors. Similarly, the child node's origin vector is set to 1-1, but this actually moves it to 2-1 in world space due to the parent node's basis vectors. To calculate a child's transforms, world space transform manually, this is the code we would use. In actual projects, we can find the world transform of the child by applying one transform onto another using the star operator. Note, when multiplying matrices, order matters, don't mix them up. Lastly, applying the identity transform will always do nothing. If you would like additional explanation, you should check out 3 Blue 1 Brown's excellent video about matrix composition. Inverting a transformation matrix. The affine inverse function returns a transform that undoes the previous transform. This can be useful in some situations. Let's take a look at a few examples. Multiplying an inverse transform by the normal transform undoes all transformations. Transforming a position by a transform and its inverse result in the same position. How does it all work in 3D? Don't need to worry about 3D. Presenting rotation in 3D. Don't need to worry about 3D. Huzzah, halfway through. Interpolation. Interpolation is a common operation in graphics programming, which is used to blend or transition between two values. Interpolation can be used to smooth movement, rotation, etc. It's good to become familiar with it in order to expand your horizons as a game developer. The basic idea is that you want to transition from A to B. Value t represents the states in between. For example, if t is 0, then the state is A. If t is 1, then the state is B. Anything in between is an interpolation. Between two real floating point numbers, an interpolation can be described as that, and often multiplies to that. The name of this type of interpolation, which transforms a value into another at constant speed, is linear. So when you hear about linear interpolation, you know they are referring to this formula. There are other types of interpolations which will not be covered here. A recommended read afterwards is the Bezier page. Vector interpolation. Vector types, vector 2 and vector 3, can also be interpolated. They come with handy functions to do it, vector 2 lerp and vector 3 lerp. For cubic interpolation, there are also vector 2 cubic interpolation and vector 3 cubic interpolation, which do a Bezier style interpolation. Here is example pseudocode for going from point A to point B interpolation. It will produce the following motion. Transform interpolation. It is also possible to interpolate whole transforms, make sure they have either uniform scale or at least the same non-uniform scale. For this, the function transform3D interpolate with can be used. Here is an example of transforming a monkey from position 1 to position 2, using the following pseudocode. And again, it will produce the following motion. Smooth motion.
Oh, I should probably, tell you what has been changed about the mod pack.
Later.
Okay.
I'm reading, and if you tell me now, then it delays risk of rain.
You know, that's a fair point.
Also, I do need to eat, so that's also a heads up. Interpolation can be used to smoothly follow a moving target value, such as a position or rotation. Oh, guess he's going to eat. Each frame, lerp, moves the current value towards the target value by a fixed percentage of the remaining difference between the values. The current value will smoothly move towards the target slowly down as it gets closer. Here's an example of a circle moving the mouse using interpolation smoothing. Here's how it looks. This is useful for smoothing camera movement for allies following the player, ensuring that they stay within a certain range, and for many other common game patterns. Note, despite using delta, the formula used above is frame rate dependent because the weight parameter of lerp represents a percentage of the remaining difference in values, not an absolute amount to change. In physics process, this is usually fine because physics is expected to maintain a constant frame rate, and therefore delta is expected to remain constant. For frame rate independent version of interpolation smoothing that can be that can also be used in a process, use the following formula instead. Deriving this formula is beyond the scope of this page. For an explanation, see improved lerp smoothing, or watch lerp smoothing is broken. Next. Beziers, curves, and paths. Bezier curves are a mathematical approximation of natural geometric shapes. We can use them to represent a curve with as little information as possible, and with a high level of flexibility. Unlike more abstract mathematical concepts, Bezier curves were created for industrial design. They are a popular tool in the graphic software industry. They rely on interpolation, which we saw in the previous article, combining multiple steps to create smooth curves. To understand how Bezier curves work, let's start from its simplest form, quadratic Bezier. Quadratic Bezier. To take 3 points, the minimum required for quadratic Bezier to work. To draw a curve between them, we first interpolate gradually over the 2 vertices of each of the 2 segments formed by 3 points, using values ranging from 0 to 1. This gives us 2 points that move along the segments as we change the value of t from 0 to 1. We then interpolate Q0 and Q1 to obtain a single point R that moves along a curve. This type of curve is called a quadratic Bezier curve. Image credit Wikipedia. Cubic Bezier. Building upon the previous example, we can get more control by interpolating between 4 points. We first use a function with 4 parameters to take 4 points as an input: P0, P1, P2, and P3. We can apply a linear interpolation to each couple of points to reduce them to 3. We then take our 3 points and reduce them to 2 and to 1. Here is the full function. The result of the smooth curve interpolating between all 4 points. Image credit Wikipedia. Note, cubic Bezier interpolation works the same in 3D, just use vector 3 instead of vector 2. Adding control points. Building upon cubic Bezier, we can change the way 2 of the points will work to control the shape of our curve freely. Instead of having P0, P1, P2, and P3, we will store them as point 0. P0 is the first point, the source. Control 0 equals P1 minus P0 is a vector relative to the first control point. Control 1 equals P3 minus P2 is a vector relative to the second control point. Point 1 equals P3 is the second point, the destination. This way we have 2 points and 2 control points, which are relative vectors to the respective points. If you've used graphics or animation software before, this might look familiar. This is how graphics use software. Software presents Bezier curves to the users and how they work and look in Godot. Curve 2D, Curve 3D, Path, and Path 2D. There are 2 objects that contain curves, Curve 3D and Curve 2D. For 3D and 2D respectively, they can contain several points, allowing for longer paths. It is also possible to set them to nodes, Path 3D and Path 2D, also for 3D and 2D respectively. Using them, however, may not be completely obvious, so following it is a description of the most common use cases for Bezier curves. Evaluating. Only evaluating them may be an option, but in most cases it's not very useful. The big drawback with Bezier curves is that if you traverse them at constant speed from t0 to t1, the actual interpolation will not move at constant speed. The speed is also an interpolation between the distances between points p0, p1, p2, and p3. And there is not a mathematically simple way to traverse the curve at constant speed. Let's do an example with the following pseudocode. As you can see, the speed in pixels per second of the circle varies, even though t is increased at constant speed. This makes Beziers difficult to use for anything practical out of the box. Drawing Beziers, or objects based on the curve, is a very common use case, but it's also not easy. For pretty much any case, Bezier curves need to be converted to some sort of segments. This is normally difficult, however, without creating a very high amount of them. The reason is that some sections of a curve, specifically corners, may require considerable amounts of points, while other sections may not. Additionally, if both control points were 0, 0, remember they are relative vectors, the Bezier curve would just be a straight line, so drawing a high amount of points would be wasteful. Before drawing Bezier curves, tessellation is required. This is often done with a recursive or divide and conquer function that splits the curve until the curvature amount becomes less than a certain threshold. The curve classes provide this via the curve2D tessellate function, which requires optional stages of recursion and angle tolerance arguments. This way, drawing something based on a curve is easier. Traversal. The last common use case for the curve is to traverse them. Because of what was mentioned before regarding constant speed, this is also difficult. To make this easier, the curves need to be baked into equidistant points. This way, they can be approximated with regular interpolation, which can be improved further with a cubic option. To do this, just use the curve3D sample baked method together with curve2D get baked length. The first call to either of them will bake the curve internally. Traversal at constant speed then can be done with the following pseudocode. Last one before stream end. Random number generation. Many games rely on randomness to implement core game mechanics. This page guides you through common types of randomness and how to implement them in Godot. After giving you a brief overview of useful functions that generate random numbers, you will learn how to get random elements from arrays, dictionaries, and how to use a noise generator in GDScript. Lastly, we'll take a look at cryptographically secure random number generation and how it differs from typical random number generation. Note, computers cannot generate true random numbers. Instead, they rely on pseudo-random number generators, PRNGs. Godot internally uses the PCG family and pseudo-random number generators. Global scope versus random number generator class. Godot exposes two ways to generate random numbers, via global scope methods or using the random number generator class. Global scope methods are easier to set up, but they don't offer as much control. Random number generator requires more code to use, but allows creating multiple instances, each with their own seed and state. This tutorial uses global scope methods, except when the method only exists in random number generator class. The randomize method. Since Godot 4.0, the random seed is automatically set to a random value when the project starts. This means you don't need to call randomize in ready anymore to ensure that results are random across project runs. However, you can still use randomize if you want to use a specific seed number or generate it using a different method. In global scope, you can find a randomize method. This method should be called only once when your project starts to initialize the random seed. Calling it multiple times is unnecessary and may impact performance negatively. Putting it in your main scene script ready method is a good choice. You can also set a fixed random seed using seed. Doing so will give you deterministic results across runs. When using the random number generator class, you should call randomize on the instance since it has its own seed. Getting a random number. Hello, Bella. Let's look at some of the most commonly used functions and methods to generate random numbers in Godot. The function randa returns a random number between 0 and 2 to the power of 32 minus 1. Since the maximum value is huge, you most likely want to use the modulo operator to bound the result between 0 and the denominator. Randf returns a random floating point between a point number between 0 and 1. This is useful to implement a weighted random probability system, among other things. Randfn returns a random floating point number following a normal distribution. This means the return value is more likely to be around the mean 0 by default, varying by the deviation 1 by default. Randfrange takes two arguments from and to and returns a random floating point number between from and to. Randorange takes two arguments from and to and returns a random integer between from and to. Get a random array element. We can use random integer generation to get a random element from an array, or use the array pick random method to do it for us. To prevent the same fruit from being picked more than once in a row, we can add more logic to the above method. In this case, we can't use array pick random since it lacks a way to prevent repetition. This approach can be useful to make random number generation feel less repetitive. Still, it doesn't prevent results from being ping-ponging between a limited set of values. To prevent this, use the shuffle bag pattern instead. Get a random dictionary value. We can apply a similar logic from arrays to dictionaries as well. Weighted random probability. The randf method returns a floating point number between 0 and 1. We can use this to create a weighted probability where different outcomes have different likelihoods. You can also get a weighted random index using the weighted method on a random number generator instance. This returns a random integer between 0 and the size of the array that is passed as a parameter. Each value in the array is a floating point number that represents the relative likelihood that it will be returned as an index. A higher value means the value is more likely to be returned as an index, while a value of 0 means it will never be returned as an index. For example, if 0.5112 is passed as a parameter, then the method is twice as likely to return 3, the index of the value 2, and twice as likely to return 0, the index of the value 0.5, compared to the indices 1 and 2. Since the returned value matches the array size, it can be used as an index to get a value from another array as follows. Better randomness using shuffle bags. Taking the same example as above, we would like to pick fruits at random. However, relying on a random number generation every time a fruit is selected can lead to a less uniform distribution. If the player is lucky or unlucky, they could get the same fruit or more times in a row. You could accomplish this by using the shuffle bag pattern. It works by removing an element from the array after choosing it. After multiple selections, the array ends up empty. When that happens, you reinitialize it to its default value. When running the above code, there is a chance to get the same fruit twice in a row. Once we picked a fruit, it will no longer be possible to return it will no longer be a possible return value unless the array is now empty. When the array is empty, we've reset it back to its default value, making it possible to have the same fruit again, but only once. Random noise. The random noise generator shown above can show its limits when you need a value that slowly changes depending on the input. The input can be position, time, or anything else. To achieve this, you can use random noise functions. Noise functions are especially popular in procedural generation to generate realistic-looking terrain. Godot provides fast noise light for this, which supports 1D, 2D, and 3D noise. Here's an example of 1D noise. Cryptographically secure pseudo-random number generation. So far, the approaches mentioned above are not suitable for cryptographically secure pseudo-random number generation. CSPRNG. This is fine for games, but this is not sufficient for scenarios where encryption, authentication, or signing is involved. Godot offers a crypto for this class. This class can perform asymmetric key encryption, decryption, signing, verification, while also generating cryptographically secure random bytes, RSA, keys, HMAC, digests, and self-signed X509 certificate. The downside of CSPRNG is that it's much slower than pseudo-random number generation. Its API is also less convenient to use. As a result, CSPRNG should be avoided for gameplay elements. Example of using the crypto class to generate two random numbers between 0 and 2 to the power of 32 minus 1 inclusive. See also packed byte arrays documentation for other methods you can use to decode the generated bytes into various types of data, such as integers or floats. Onto navigation. Oh, wait. Okay, it doesn't have any description here.